Mic check. Stream is a bit quiet. Let's bump up the stream. Okay, let's see if it helps when I get actually into the zone. So if you don't hear me well, like, I'm gonna fix this right now, just pretty hard. Okay, if you still don't hear me well, you can double press both of your triggers and click fix audio. It should fix most of the issues when something is not working or is too quiet or whatever. So if you have any of those issues, you can do that. If it's still too quiet and nothing seems to be helping, sadly the only thing I can suggest is rejoining, but hopefully that's not gonna happen too often today. But we'll see. I tried to fix some of the things from yesterday. So yeah, and with that, welcome to day 2 of TLX. So today we still have quite a bit of content left. We will be talking about licensing right about now, but there are still a bunch of cool talks. I'm really excited about the shader talk, which will be at the very end. So I definitely encourage you to stick around. But yeah, if anything still comes up, if you have any issues, please find me somewhere and tell me about them, because I'll still be trying to fix it all later. The recording should be more stable today, so let's see how that goes. But yeah, if anything, there is a stream, which you can also see by double-clicking, like what the stream sees by clicking both of your triggers together, and you can have a better view at what's on screen, like if it's code or something like that, which is hard to see in VR from so far. Press both of your triggers, gets the screen up close, so you can actually look into all of the code that is there. And yeah, and I think with that, we're just gonna be starting because why not? So I'm gonna be switching to the next presentation, and yeah, we'll be kicking it off. So you can come here for a moment. You can just get in and take control, and we'll be off. And press start when you start.
All right.
Okay.
Okay. Hello, everyone. Oh, sorry?
Yeah, all good. All good.
Yep. All right. Hello, everyone. Thank you for coming. So to start off the day today, we're going to be talking not so much about creating worlds, but about how to handle your creations before and after you make them. I am Redhound. I am an attorney licensed in the state of California. I represented tech companies large and small in a variety of intellectual property and business matters for 10 years. So I've done this kind of thing for a while. However, professional norms require me to state that none of what I'm about to say is legal advice. If it was legal advice, I would need to ask you a lot more questions about your specific situation. One issue being the further you get from California, the less I know about exactly what laws apply. But in general, the principles I'm talking about today should apply in most situations. There's a lot of commonality on the things that control licensing throughout the world. So first off, why care about licensing? A lot of people, they sort of they're hesitant to get involved in any sort of license situation because it's complicated. They're worried people will be offended. Why not just rely on people's common sense? And the reason is that everyone's common sense is different. And so the reason that you want to actually think about your licensing is clarity. Just communicate to yourself and to everyone else what it is that you expect about how your material is going to be used. And indeed, even outside of the license, that's kind of a good thing to think about. I mean, how would you feel if people used your material in XYZ sort of way? Another thing is if you're doing commissioned work, especially for people outside of the community, like when a TV network wants a VR world, something like that, they may have needs that you're going to need to kind of understand. And the last thing is also that you are users of licenses. The tools that you use, the assets that you use, those are also controlled by licenses. Unity, VRChat, all of those you are using licensed material from them. And in general, those licenses are very broad and shouldn't limit you in any way, but it's good to be aware that that's a thing that's happening. So first I want to go over kind of the basics of how contracts work. And you may know some of this, but it's just good to have it all in one place. So basically a contract consists of four things. There's an offer, someone says, hey, let's make this agreement. There's an acceptance, another person saying, yes, I agree, let's make that agreement. Intent, you both actually intend, this is an agreement, this is going to be binding on both of us. And consideration, there has to be some kind of obligation on both sides. So if you just say, hey, I'm going to do this thing, and someone says, yes, I agree that you're going to do that thing, that's not a contract, that's just a promise. Am I? I'm sorry.
You want to click next one more time, so you're
okay.
Like,
yeah, I'm sorry.
The next slide.
You're right. I am. I'm so sorry. Okay, so
It's okay.
I apologize. One thing that's important to note: a contract does not have to be formally signed. All of the things that you think of when you think of a contract, you can have a contract without those things. A contract doesn't have to be signed. It doesn't even have to be written down. But whenever you can, you do want to write it down because, as I said, the point of all this is clarity. You want to make sure that you and the people you're making agreements with have the same understanding of what it is that you're doing. Now, sometimes that's not possible. So on the internet, we often see a lot of what are called in the biz browse wrap agreements, where the idea is someone says, hey, this is the agreement under which you can use my stuff. And if you use it, that's you agreeing to these terms. And that works. That has been held to be sufficient. But it does get a little dodgy because if there's an argument, people sometimes say, well, I didn't know, I didn't see those terms, I didn't agree to them. So working it out in detail is great if possible, but again, sometimes it's not, especially when you're not actually going to be in communication with the people who are going to be using the things that you distribute. And then a little basics on copyright. So copyright is the main intellectual property right that covers artistic works and software. And copyright comes into existence at the moment that something is created, and it belongs to the person who created it unless that person is creating it for their employer, which I don't think is the case for anyone here. So at the moment you create something, you own the copyright in it. And that means that you have the right to stop people from doing various things with your work, to stop them from copying it, to stop them from distributing it, to stop them from changing it. But you can give permission. You can give, that's what a license is, giving permission to someone to do something with a work where you own the copyright that they wouldn't otherwise be able to do. One issue that can come up, particularly with freely distributed material, is sometimes people think, hey, it's on the internet, it's free, I can do whatever I want. And that's not true, but there is a certain extent of, if you put something on the internet, it's sort of implied that you expected people to look at it. If you put something up for free download, if someone then downloads it, there's an argument to be made that even though you didn't say, I give you a license to do this, there's what's called an implied license for that. Again, though, without the clarity, that can get kind of mushy. So as I say, we're looking for clarity. We're looking for understanding what it is that we want in our license. And the first step in that is kind of thinking about, what is it that you want? What are you trying to accomplish? What do you care about in how people use your work? So a big one is probably the biggest one for a lot of people is attribution. If you use my stuff, tell people that you used my stuff. Let people know that I did that. So a lot of people care a lot about that. And a tricky thing is attribution is not one of the rights in copyright. You have to get that. You have to get an agreement for attribution. You can't, I guess what I'm saying is you cannot force people through copyright to give you credit. It's not one of the things that's within copyright. And so that's one of the things that a license can do for you. Another thing that's important a lot is commercial use. Often people are happy for people to use things personally, just doing your own thing. But if you're making money from it, I don't want you to do that. Or I want to cut. Or I want you to come talk to me and we'll figure out what we're going to do. Another big one is redistribution. A lot of times, especially in a commission context, people will be like, okay, so I'm going to make this thing, I'm going to give it to you, and then you can have it and you can do what you want with it, but you can't then give it to other people. And actually, especially for things that I'm wrong, a commission's not the biggest thing for that. Probably the biggest application is where you're distributing something, but you want to be the source of it. if you have a thing, someone says, hey, that's awesome, you want them to say, okay, yeah, you need to go to that place where I have it for download, not, hey, I'm going to just send you a copy and have it go all over the place. And then another thing that comes up sometimes is people care about specifically how something's going to be used. So people sometimes will make assets for use in a specific context on a specific platform. So I'm going to make you this avatar, but this is for VRChat. You can't use this to stream, or as a VTuber, or any number of other things. Or also a thing that comes up a lot is people say, I don't want you to use my assets for porn. That's a big one that you see in the license sections of a lot of asset stores. And you could have any number of those kinds of things that you care about. What is the way that things get used that would hurt your feelings, that would upset you? And so think about that. Think about, how do you want people to use your stuff? How would you be upset if they used your stuff that way? And then when you have that in mind, you'll be able to kind of think more clearly about how to achieve that. The last comment here, think about enforcement. One thing you need to think about is that often on the internet, people are going to do what they're going to do. And they can do stuff that's against the terms that you put out. You may not be able to stop them. And that is what it is. And it's still worthwhile telling people what you want, because most people will honor that. But, licenses aren't magic. They don't enforce themselves. The second thing you want to think about is, how are you going to be distributing your assets? So obviously, if you're building worlds, mostly that's going to be within the context of VRChat. But this is more about, like, if you make prefabs, I assume most of you make prefabs. If you make avatars, any sort of asset, you want to think about, how do you intend to distribute it? So, a big way is through various stores, the Unity store, VCAT, Booth. Those all have their own terms of service about what you can do. And that will put some limits on what you're able to call for in your license. For example, the terms of service on the Unity store don't allow you to require attribution in the license. You can use a variety of licenses, but not ones that require attribution. And so that puts some limits. And if attribution is really important to you, maybe you don't want to use the Unity store for your stuff. Booth and VCAT, as far as I know, do not put significant limits on it. However, I don't trust the translations of their terms of use, so there may be aspects I don't know about. But my impression is that Booth and VCAT have a lot more free-form licensing regime. You can kind of put whatever you want in the licensing section. Another option is you can distribute it yourself. You can put stuff up on Dropbox or Google Drive or any number of other places. You may have your own website. And those are great in that you can do whatever you want there. You can control the release. Of course, you then have to pay for the hosting. And then in some cases, you may be distributing things directly. So if you're doing commissions for one person, you're not making it publicly available. You're just, sending the final asset to the commissioner. So that's the other thing that you want to think about before you kind of think about, what kind of license do I want to use? Which brings us to, what kind of licenses might you want to use? We're going to start with the ones that are what you might call plug and play licenses, prefab licenses. These are the ones you've probably heard of, where there's a license out there, people kind of know what it is, it's been drafted by lawyers, and you can just kind of slap it on and it's easy. And that is great. The only limitation is that it may not do what you want. So first we're going to talk about Creative Commons. There are 7 Creative Commons licenses. They do different things, but there are basically 3 variables that you might care about that Creative Commons deals with. The first one, like we talked about, is attribution. The second is derivative works. So if you want to distribute something and have people be able to access it freely but not to change it, that's something Creative Commons can do for you. And then the last thing is whether you want virality of the license, whether you want anything that someone does with your work to be covered, that they cover what they do with the same license that you used. And so to run through them. So the first one is the CC0 license. And that's one where you don't want to put any limitations. That's when you just want to say, like, look, to the extent that I can, I'm not claiming copyright on this. You can do whatever you want with it. It's the most permissive license. The main reason it exists is that, when you just put something out on the internet, people might be like, well, that seems cool, I want to check it out, but am I going to get in trouble? What are they going to do? There's no license, there's no clarity. And so when you put in the public domain license, you're making clear to your users, you can use this. You can use it any way you want. You are safe from me. The second one is the attribution license. When you put that license on something, it says you can distribute this, you can do whatever, you can change it, you can do whatever you want. You just have to make clear that I did this part of it. Attribution share alike. It's like attribution, but again, there's a requirement that if you do something based on this work, you have to put this license on it. It has to stay in this relatively open space. Attribution, no derivs. Again, you kind of get the point here. You got to do attribution, can't do derivative works, can't change anything about the asset. And then attribution non-commercial. I was wrong. There's one other variable, which is commercial use. So attribution non-commercial is, I want you to give me credit, and I don't want you to use what you do with this for any sort of commercial use. They all involve attribution, except for public domain. And then there's the ones that are just combos of the others. Attribution non-commercial share alike. You have to credit me. You can't use it commercially, and you have to put this license on anything else that you do with it. And then attribution non-commercial, no derivs. You have to credit me. You can't use it commercially, and you can't change it. You can't do anything based on it. Creative Commons is pretty well known, and the licenses are pretty simple, and they're well drafted. And so if those sets of situations describe you, then they're a real good choice for that. If you need something else, then that's going to be an issue. The second category of prefab licenses you might look at is the open source licenses, which are mostly used for software, but can also be used for digital assets of other kinds. The three most popular ones that are potentially relevant are the MIT license, the BSD license, and the Apache license. They basically all do the same thing. There's kind of three prongs to it. One, attribution. You have to credit me when you do whatever you're going to do. Two, you can do whatever you want to do. You want to make derivative works? Great. You want to use commercially? Great. Whatever. And then the third is, if you get yourself into deep trouble doing whatever it is that you do, that is not on me. I have no liability for that. Those are the three clauses that are in the major, relatively light open source licenses. There are varying lengths. MIT and BSD are short, Apache's long, but it's basically the same material. There are other open source licenses that are a little heavier. You may know the GPL. For the most part, those licenses I don't think are appropriate for digital assets. They are complicated, there's a lot involved, and frankly, I wouldn't recommend that you use them without having a lawyer talk to you about what's going on. So those are the pre-made licenses, which brings us to custom terms of use. Terms of use like you see on a website, and which I know a lot of artists use for their publicly distributed materials. And you can put whatever you want in there. Because, like we said, a contract can be anything. You can put whatever you want, and because you're saying, hey, these are the terms under which you can use it, that can be a contract. However, if you're not thoughtful about how you draft it, you're not going to achieve the clarity that we're looking for. So for example, I've seen terms of use where the first line is no restrictions, you can do whatever you want with this, and then a couple lines down it says no commercial use. And that, which one are you saying? So you want to kind of think about it, be clear, be consistent within your terms of use. And because you want to think about it and be clear on what you're trying to do, I recommend you don't just copy someone else's from online, because that does what they want it to do. It may not do what you want it to do. But you don't need a lawyer to do this. You just need to be clear about what it is that you want, and then you need to say it. Which brings us to commissions. Situations where someone is paying you specifically to make stuff for them specifically. Again, it doesn't have to be very complicated. It doesn't have to be very formal. What it has to be is clear. You need to communicate with your client about what it is that they want in detail, and how are you going to get it done for them, and how are they going to pay you. And for this, a written agreement is really helpful because it gets everything that you want to deal with in one place. It's all in one place. You can both say, hey, this is the agreement. All right, we know what we're going to do, and we know what we have to talk about if something has to change. And this doesn't have to be printed. You know, you can have an email. You can have a binding contract in text messages or DMs, but it is absolutely best practices to get everything in one place, so you can both be like, yes, this is the agreement, and you don't have misunderstandings that way. Some specific things that you should think about, and you know, I mean, these may seem elementary, but a lot of people kind of feel like some of this is implied or goes, you know, you can take it for granted, and then it turns out no, you can't. So those issues are, you know, the big one is price. How much are you paying? People don't usually forget that one, but they do sometimes forget how are you paying, when are you paying, what happens if you don't. I mean, that goes back to the enforceability problem. But, you know, thinking that through and being specific, always useful. The second thing is, what exactly are you doing? And when are you doing each part of it? You know, so if, for example, you're doing multiple assets or multiple stages, you know, maybe there's a, hey, I'm going to do the draft by this date so you can see how it's going. We can talk about it if anything needs to change. And then the final deliverable will be on this date. You know, thinking about that kind of thing very clearly is very useful. Change orders. What happens if someone wants to change it? You know, what happens if the client says, you know what, I thought about it, I want it to be purple instead? Do they have to pay you more? How late in the game can they make changes before you start having to talk about changing the whole thing? And then the last one gets back to the IP side of things, is which rights are transferred? You know, because one of the things in intellectual property that confuses people, the classic example is wedding photos. You know, people hire photographers, they pay them a lot of money to come take pictures of their wedding. And then they find out afterwards that they don't own the pictures. They get to pay the photographer more for copies of the pictures because the photographer created those pictures and owns the copyright. And people get very upset about that. And so it's good to be clear about, well, who owns things? Like, if I commission something from you, are you selling me the copyright? Or are you just selling me a license to use it in certain ways? And this is a big one where people's expectations are not always in the same place. And so it's good to be clear about what are those terms, what are the limitations on what rights are being transferred. And that is the major topics I wanted to get through. We have, it looks like 10 minutes left if there are any questions. If you have other questions beyond that, you can reach me at Discord or at Twitter.
Okay, same as yesterday, we have a question zone over there, so if you have any questions, please line up and get into the circle one by one, and yeah, should be good.
Yeah, good in there. So I was wondering, since I do commission work, I'm doing one currently, so when I distribute the assets to them, should I like give them a written document, like a notepad or something, saying, hey, you own all the rights to this, to make sure nothing ever happens in the future? Or so they can like do their own DMCAs and whatnot, since for them to own the right to that model?
That is actually an excellent point. DMCAs are, you know, for a lot of people, one of the big issues that can come up. You know, I think it would, if they want that, I think that would make a lot of sense. I'm not sure that's really on you. You know what I mean? Like, if they didn't ask for it when you made the agreement, you know, you don't have to do it. But certainly I think it might be good client service to say, like, hey, do you want some sort of written assignment of the IP here? And they can say yes or no. Yeah. You could even say, hey, I'm going to need more money for the assignment of rights, but that might not be very classy.
So putting it on a notepad when sending the model file, is that, what is it, good enough for something like that, or does it have to be something more?
Just like sending a text file along with the assets?
Yeah.
I'm not sure. I'm not sure. Like by Notepad, do you mean like the Windows software?
Yes.
Or is there a,
that's what I meant.
Yeah, that would
Yeah, like a
that's
text
fine.
file.
I mean, if you think about it, like when you
Okay.
download software, right? Often the EULA is just a text file. You know, so that's absolutely fine. I should say the reason that people do all of the formalities is that if there's a dispute and lawyers and courts get involved, you get into issues of how do you prove it. You know, and when you've got the more concrete your agreement is, the easier it is to prove to an outside party, here's what we intended. However, for most digital asset work, the amount of money you're dealing with, it's almost never going to be worth getting lawyers and courts involved. You know, and so what you need to do at this level is just try to avoid the dispute from happening in the first place.
Okay. All right. Thank you.
Hello. First of all, thanks a lot for your talk. I was wondering, we talk about commercial use, but nowadays we have ads, we have YouTubers, we have streamers, we have patrons. What counts as commercial? I was wondering.
Well, and that's the thing. There's not a legally defined, that's not in the law. That is a term that you have to work out, and to some extent you can leave it, there's some amount of common sense involved. But you're right that, like, is it commercial use if you use something on a stream where you're getting ads or donations? People have different feelings about that. And that's why it's good, if you know that that's a situation that might happen, to talk about it. To say, like, I don't want you doing this kind of work. That's what I mean by commercial use. There's not sort of a, this is commercial use in all situations. Now, I should say, actually, this is one of the shortcomings of the Creative Commons licenses. Because there are these categories that are relevant that aren't very clear on the line between commercial and non-commercial. So that is a shortcoming of the prefab licenses.
Thank you.
Yeah, I was wondering, how is it, definition-wise, where, for instance, fair use comes into place, and how would you define it, or even defend against it, or plead for it? Like, how do these boundaries happen? Like, what could constitute, especially in the context of, like, avatars or worlds? You see people basically recreating a lot of things from their favorite media, and where could fair use go, and where does it end? Mm-hmm.
So this actually is a tricky topic, and so a cynical thing that we say in IP law is fair use is the right to hire a lawyer. There isn't a very clear line about what is fair use, what is not fair use. I will say, almost any time, like, you see a YouTube video where there's a long thing at the beginning where they talk about how what they're doing is fair use, it almost certainly isn't. People on the internet have bad understandings of what fair use means. Fair use, there are a lot of different types of fair use, but in general, fair use is when you are using something because you needed that thing in order to comment on it, right? So, like, if you're making, I don't know, a parody of some anime, right? Well, if you're making a parody, you need to be able to, at some level, copy the characters and the situations, because otherwise you can't do the parody. That's sort of a core fair use kind of situation. Or if you need to comment on things.
Mm-hmm. Yeah, like a good example in VRChat, like the Knuckles thing. It's basically a Sonic or Sega-owned character that has been satire modified, and yeah. So would that, for instance, be fair use or outside?
Again, there's not a hard and fast rule on this, because at the end of the day, a court has to decide. There's a bunch of different factors, and a court has to kind of work out, how do they weigh. But in general, something like that, I think, is more likely to be fair use. A lot of people think that fair use and non-commercial are the same thing. That they're like, oh no, I just wanted to rip this character because I love it so much, and no one's paying me for it. That feels like it should be fair, but that's not what fair use is for. So that kind of thing is not likely to be fair use in the legal sense.
Thank you.
Does that answer your question?
Yeah, mostly, yeah.
Terrific.
Right. So an earlier question brought up that sending in like a text document with your asset that would, constitute coverage. But at what point should you be asking them to like sign a document, like an online signature type thing?
As I said, it's about enforceability, and so that's up to you. I mean, actually,
if worst comes to worst.
Yeah, I mean, if you've got someone's signature on something, it's a lot easier. If they say, no, we never agreed to that, and then you're like, you signed this document.
Right.
If this wasn't our agreement, you should have said something before you signed it. That's the use of signatures. Now, I'll say, like I said, it's almost never useful in this arena to bring in lawyers in courts. Where you may come into play is if you have to talk to platforms. You got to talk to an asset store where someone is selling your stuff. You got to talk to VRChat where someone's doing something. In those situations, it may help to have a more robust paper trail. But it's not like a limit. It's not like this is enough, this is not enough. The more detailed documentation you have, the more safety you have. But at the same time, it's a lot of work. And it may not be worth it for you. So, yeah, I don't know that's a very helpful answer, but that's how it is.
No, that's good. Thank you.
Okay. I have two questions from the live stream chat. First one is from Legends.
Can I just interject? Are we good on time? Because I see the...
Yeah, we're fine. We started a bit earlier, so we can definitely take last question.
Definitely get the time.
Great.
First one is from Legends. Can you give a client the terms of use when you send them the project file, or should you agree on that before you do any payment?
You should agree on it beforehand. Yeah, you should work. I mean, because think about it. You should work out what are the conditions for how you're going to do this work together before you do the work. If you send them the terms of use at the end, I mean, they may respond like, what? That's not what I wanted. That's not what I thought was going to be the case. And completely aside from an issue of who's in the right, I mean, you don't want people to be upset with your work because they thought it was going to be something other than it is. Now, if you're in the middle of a commission right now, it may be not a bad idea to reach out to your client and be like, hey, I just wanted to kind of, make explicit what are the parameters of our deal. But in general, you always want to do it ahead of time.
Thank you for that. Second one is from Centauri. If you have a contract with the company that doesn't explicitly state that the work you create for them is owned by them, is it implicit that the work is owned by me or owned by the company?
It's owned by you.
Okay.
Unambiguously, it's owned by you. Now, two caveats. One, there's what they call work for hire. Work for hire is when you are their employee. When you work for them, the work you do for them belongs to them. And there are a limited set of circumstances where a contract relationship can create a work for hire. It's a whole list, and I don't remember it off the top of my head. But it kind of has to do with if a company is hiring you to make more of like their stuff, they're more likely to own the rights. But in general, if you're in a contract situation, the company should be asking you to assign rights if they want to own them. If they didn't do that, then they don't. There's some issue here of implied license. Like if the whole point of it was, hey, we need you to make this asset for this purpose, you're kind of going to need to let them do the purpose because that was pretty clearly part of the deal. But the actual ownership, if it wasn't transferred, it stays with you.
Yeah, then I think that would answer that then. So thank you.
Great.
And that was it.
Yeah, thank you so much.
Okay, so if that's everyone, thank you so much for coming. Again, if you have any questions, I'm happy to talk.
Yeah, and with that, we're gonna have a 5-minute break, and we'll then come back to FSP. I'm pretty sure. So yeah, I'll see you in 5 minutes.
That was great.
That was really good talk. Thanks.
Thank you. Thank you.
Bad news.
Glad it
That
was
was really nice. Very
Yeah, nice
informational.
talk.
button and see what horrible things happen. Oh, good. Current slide appears to be correct. And if I hit the start button, you should have some nice slides up. Fantastic. Hi. This is a weird talk, because when I said I wanted to do a retrospective on Slaughterhouse 2, I was sort of thinking a few people inside the world playing it for a bit and having some thoughts on basically how the project went. And instead, I'm standing in front of like 20 people on a stage. So, wasn't exactly what I was imagining, but I will just say firstly, this talk is, and my style of presenting is quite scattershot, quite unfocused. I also talk quite quickly. So I'm going to try and stop doing the latter of those, but I also wanted to start off with something a bit amusing and sort of a theme of this talk first. So, my name is FairlySadPanda. It's just old Panda for short. And my first ever full-time paid job was working at Sony Computer Entertainment Liverpool on a set of Sony exclusive games which we were QA testing. The first two of those games were... Do we have a nice thing here for pointers? We do. Can I blind people with it? No. So we've got Beyond Two Souls on the left, which I worked on the PS3 and PS4 versions of, and Killzone Shadowfall. I also worked on Little Big Planet 3 and a few smaller projects. And I mention this because whenever I think back to my history in game design and what I learned from that, I always said that QA is the most important job I ever had. And normally when I give this talk, it's on a private Discord call, and I can talk about various anecdotes which are both amusing and examples of how projects can explode. I can't because we're recording this and I think I'm still under NDA and I don't really want to be sued by David Cage. So for this, I'll just, if you ever want to hear these stories, hit me up on the Discord. But one of them does involve a flying motorcycle caused by a clock, which is rather interesting. But the theme I learned when I was doing QA was games are hard. Games are really hard. Games are probably the second hardest thing you can do in software other than, name things or send rockets to Mars. Games are that hard. And the reason is because games are incredibly subjective. Remember, I worked on these two games. These two games, I think the other game is Little Big Planet 3, which is not really part of this talk. These games, both of them were mediocre scores on Metacritic. 72 for Beyond Two Souls, 73 for Killzone Shadowfall. And I don't think the latter of those two games, I don't think is a bad game. But I do think the former is an absolutely abysmal game. And I'll mention why on the next slide. And it's a theme of game design is why these two games, which were spent a lot of money, a lot of time on by talented studios, QD is Quantic Dream's talented, and Guerrilla Games are extremely talented, of course. One of the games of the generation was Horizon Zero Dawn. They both produced mediocre games. And the reason for those mediocre games, on the left-hand side, Beyond Two Souls, I can summarize, it was a bit unfair at the time. We generally said the reason why it was bad was the director, David Cage, but it was a bit more than that. It was mostly David Cage, but there was a few more things to it, mostly involving internal corporate politics. I mean, that game had everything. It had so much money behind it. It was the third game by Quantic Dream, fourth, I think it was fourth actually, after Omnicron. It was their first game. And should have been great. Had Elliot Page on board as the main actor. It had Willem Dafoe as the sort of secondary character, the second main character. And it was a complete dumpster fire. And it got 72 Metacritic score despite looking beautiful. Still looks good today on PS3. Mostly because their design was wrong. Killzone, Beyond Two Souls has dreadful game decisions pretty much all the way through. It's a choose-your-own adventure game with a memento gimmick, where even though you're doing a choose-your-own adventure game, you can't change anything because it's somebody recollecting the events of their life, which all canonically happened. This leads to a point in the game where your character dies, and the game forgets this happens before the next scene loads. This happens about twice. Other reasons being having it just basically badly, it was poorly written and squandered the actions of, probably it was their worst script, I think it was objectively their worst script, and also had a really annoying high concept you also play as a ghost gimmick, which probably wasn't necessary. Bad game design decisions always hurts a project. Whereas Killzone Shadowfall, I think, is a good game. I can sit there and tell you I think the ghost mechanic using the PlayStation 4 controller in a novel way was great. I think the actual story is fine. I think it's still graphically a fantastic game. You can play it on PlayStation 5 now at 60 FPS locked, which looks amazing. But it was rushed. It was made in 15 months by GG. They got a full brief. We were launching a game for the PlayStation 4, and they had to release it on PlayStation 4 launch day. Some of you may remember a game called Drive Club, which was the same thing, except they were allowed to delay and Guerrilla weren't. And what you got was A good IP, a fantastic, one of the best studios in the world. PlayStation 4 launch title, game built at speed, and they had to work on brand new hardware and release a multiplayer mode and a single player mode. End result, that game was rushed to hell and back. And some of you may have played this in the audience. For example, Flower has. And the multiplayer in that game is horribly unbalanced. The story mode is forgettable, despite the fact that it's got some really interesting concepts, because of the crunch, because of the rush. That game was not in a playable state 3 months prior to launch. They crammed everything in that game, shipped it, 73 Metacritic score, still sold well, PlayStation 4 launch title, still a successful project, but not a good game. And what I get to is the thing I always remember from my early history in game dev is that Killzone 4 Shadowfall would have been a great game, fantastic, really groundbreaking, great use of PlayStation 4, but it was rushed. Beyond Two Souls had no issue with crunch, it had a great, easy path to launch, and was crap because their game design was bad. Objectively poor, wrong decision, wrong decision, wrong decision, all the way through. Squandering great actors, spending a lot of money. It didn't cause the studio any trouble because the game still sold well, because it had Willem Dafoe and Elliot Page, but it really is easily Quantic Dream's worst game. And it comes on to these two quotes. You will have all heard the Miyamoto quote. It is probably the most famous project management quote, which is quoted on the internet because it was by Shigeru Miyamoto, right? A delayed game is eventually good, but a rushed game is forever bad. It'd be lovely if we could just delay games forever in the games industry, and some people can, like Blizzard. But for most of us, we have to release in prefabs, in VRChat, we have to release because it's either a project that's been eating us up, or it's been going for a year, or there's a lot of reputation, or there's a commission on the line, yada, yada, yada. There's always a pressure to release your product. The second is the more important one. It is not the one brilliant decision, it is the 500 smart decisions that make a thing good. John Carmack. 500 smart decisions in a project needs you to have done projects before. It needs you to do planning. Cyan mentioned this yesterday. The reason why Devouring was successful, it had a solid plan from the beginning. Smart decisions also involve when do you cut content? When do you compromise? When do you seek outside help? When do you use a prefab? When do you stop working on the project for a bit to give yourself mental time to decompress, in the case of you have plenty of time? Basically, if you've got time, don't rush. You get the better perspective from your worlds. And with that, I want to keep in mind that that's that duopoly of design and time limit, which is a constant theme in video game development. So that brings us on to Slaughterhouse 2. Slaughterhouse 2 is a Spookality project for this year, and it didn't win any awards. It came out of the top 3 on Quest, and I'm still incredibly proud of the time I spent on that project. It's not the most successful project I've ever done. It will not be the most successful project I've ever done. It's also not finished, which is why this is not technically called a it's not a full retrospective. There's still going to be edits to this world over the next few months. Slaughterhouse 2 is a video game. I consider it a video game that's in VRChat, not a VRChat map. It's a way I look at projects is always, I could be doing this in VRChat, I could do this in Roblox, I could do this in Gary's mod, I could make my own engine for this. It's a project I chose to use VRChat as an engine for, and not some other kind of esoteric notion. So on the screen here are a couple of slides on the layout of Slaughterhouse 2. It's just so you can, when I refer to things later on, you'll know what I'm talking about. So Slaughterhouse 2 is a map taking place in a mansion. In that mansion, there are 3 floors. There's the top floor where the players start. They start in that little area there. There's the bottom floor where terrible things happen. If you've ever played Slaughterhouse 1 or 2, you'll know that, generally speaking, the further you go down the world, the worse things are for you if you're running the murderer. Second floor being, or the first floor, American's ground floor, being sort of another area where things happen. And I'll just quickly jump over to the next slide because I'll give you a bit of an overview on shape. Constant design in this world being you run around in circles. So this is the example of the top-down perspective. Players will start in this room. When they spawn, unless you're the murderer, you will spawn here, and you'll be running around like that, generally speaking. Always circuitous, always going up and down, trying to move in circles, going in and out and trying to basically complete objectives before you get hit by a murderer. And if you get hit by the murderer, you are knocked out. You have to wait till the next round. So I just want to point out, this is an example of a screenshot. Very dark. This is all taken in Unity. It's not completely reflective of what it looks like inside of VRC. It's also not completely done yet. We're still working on the graphics for it. But an example of sort of the aesthetics of the world, very plain, very basic. I should point out this is a quest world, and actually a pretty performant one too. It runs at about 50 draw calls, pretty much all the way through, with a couple of exceptions. So this talk will probably mention quite a few things as like, this is bad, I did this wrong, or we didn't have enough time for this stuff. And the map is good for a number of reasons. I really like it because, in fact, it's pretty much one of the only maps in VRC right now, with the exception of some of the stuff that Jar does, where it's a reasonably stable, there's still some bugs, it's still reasonably stable, repeatable game map with only a few remaining sort of critical bugs in it. Still, because VRChat is hard. Most of which, they're pretty rare. They're not going to interrupt your first few game sessions unless you're unlucky. They're not the kind of thing which spoils the entire map for everybody, except in certain circumstances. We'll get on to Udon later. And we're also going to talk about this case, like I said, it's not finished. And it's really cool it works. I'll be talking about how I got it working. And I also want to shout out two people. My co-worker on Project Flower of God, who was invaluable throughout the entire thing with a bunch of really good, really solid contributions to the project. And Phase Dragon for one of the, pretty much the core underlying system behind this, which is the simple object pool system. If you're doing an object pool in Udon, go download Phase Dragon's prefab. Don't do it yourself. I'm a network engineer for a living, and I can't get it working properly in VRChat right now. His one is the best we've got until Danley's netcode patch. So, it's been a learning project, and I'm still proud of this project despite the flaws I know are in it. I wrote all the code for it. I did about half the design for it. I've stood up until about 4 in the morning, 5 in the morning some nights working on it for this project. So it's going to be a case of I associate it with sleep deprivation. So, and some people, Centauri for example, you know, they're referred to as Captain Crunch. They love that. I'm like, oh god, I just want some sleep. I want to talk about the design of it now. So, generally speaking, we can categorize Slaughterhouse 1 and 2, which the 2 is the novel one, Slaughterhouse 1's a clone, as cat and mouse, or something a bit like Jar's murder maps, where you have a set of people who are all survivors. They are all on the same team. They're all trying to work together to finish goals. And those goals are on there. They have to finish a ritual, and they have to fix a generator in the basement. Then they have to evade the murderer while doing so. There's one murderer, randomly chosen at the start, and their job is simply go mad, run around making horror house references, anything you can think of, and just troll and kill all the players. Generally speaking, though, even though that sounds fun, one thing I've consistently run into with this format, it's never as fun to play as the murderer. After a few rounds, once the novelty's worn off, people don't want to do it. And I think there's a lot to do that with, again, with game design. So we tried to fix that in Slaughterhouse 2 by adding an extra couple of features. One of these being that in Slaughterhouse 2, you can go to the main room, which is that big red one on the slide, and you can pull some levers. Those levers could be change some door allocations in the maze, or drop people into a pit, or drop people into another pit, or drop people into another pit. We mostly had the same idea for this stuff. The 3 layers of the world were kind of an underpinning of that, and also time limitations. You've got to do something that makes the feature enacted but isn't going to be too hard to do in the time limit. We originally wanted to kill people during the ritual and stuff like that, and I had to get rid of that. The murderer is hard to balance. It's one of the continual things in these worlds where you got one person, how fast should they be running? Playtest. What ability should they have? Playtest. How easy is it for that person to understand what they want to do? Because they are the critical person in this world at any given time. Got a playtest. Comes back to that core point. And when you're crunching for a project to try and get it done in a couple of months of physicality, and you don't have enough time to playtest because you're the only coder on the project, that can get very rough very quickly. We, at the end of August, pretty much just before all the other craziness of VRCon and the VR Awards projects and all this other stuff, me and Flower sat on a voice call and we figured out the scope for it. And I know how important scoping is on projects. I was trying to keep it small. We thought, 2-stage game. Yeah, that'd be nice. Got an idea for sort of an obstacle course at the end. Everyone has to go through. Definitely a stretch goal. We won't go for that. And we thought we were being smart. We cut out one feature. We thought we were being smart. When it came back to this, I knew it was the first from-scratch map for both of us. I made Slaughterhouse 1. It was a clone of Piggy, a game for Roblox. It was literally a clone. Same assets. I was handed them without knowing they were ripped, but I still put it out anyways, on me for that. And I could reuse some ideas and iterate upon them, make it better, make it more like what I wanted to do with the format. We also knew that this is a quest map, and unlike Slaughterhouse 1, we can actually make this built for quests. And building request is esoteric and weird. Jordan has a bunch of good recommendations in their talk about this. But basically, we went down to, we just lower the draw calls down to about 50 and hope. And just hope nobody with quest 1s logs on, because those things are absolutely abysmal. The map appeared to be, after we scoped it all out, we had these two features. This way of unlocking the door was the same as Slaughterhouse 1. All of these features were very similar or analogous to Slaughterhouse 1, with just a new map, new design, new code, rewritten from scratch to be a lot more stable. It was only going to be a relatively easy project, right? Plenty of time. When you are doing these kinds of projects, and somebody is... You have to manage both people's time. So I work a 9-to-5 job, Flower has commissions. This means that you can't rely on somebody for your job. And this is something I refer to as a joke, and people like this, is a bus safety. Is your project bus safe? If you are working, I don't know, if the 4 ponies are working on that, for example, and one of them got hit by a bus, like Legends, for example, I don't know, would the project still be able to be completable with 3 people? What would your time limit be? How would that modify what you're able to do? If Cyan got hit by a bus, that's the only coder on the Devouring, right? How would you replace that? Would you replace that? Would the project be over, right? This kind of thing comes up a lot in open source projects, and it's definitely true with collaboration projects in VRChat. And that was both of us. Like, Flower had a lot of commission work to do. They were looking for work at the time. They were trying to make money. And I was also working on VR Wards, VRCon, and a couple of other smaller projects. And when you've got 8 weeks to work on a project, it becomes 6 weeks. Then it becomes 4 weeks. Then it becomes 2 weeks. And something I want to hit upon, as something I've made comments on personally a lot, is that a from-scratch map, something you've never done before, something you're not relying on game design for, something that you're not right doing what Jar did remaking Among Us or something like that. It is incalculably harder to make a game when you don't have a draft or something to pull off, something to really inspire you. And even though Slaughterhouse 2 is an improvement on Slaughterhouse 1, which itself is a clone, it was still novel concepts being thrown which we never tried before. And that is Project Risk 101. And we didn't properly understand that at the time, I think. And also over time limits, only spend nights and weekends on a map, lack of time for polishing and testing. We weren't willing to kill ourselves. We weren't Centauri. Which still, they won Spookality this year. That was still very good for them, but overall quite rough. And it ended up being lack of sleep, lack of enjoyment of the project, stress, up all hours, and we finished it, or I got the work done to get it done for Spookality with about 18 hours to spare. And ultimately, I'm still proud of the map. It didn't get top 3. The maps that came top were simpler than ours. Like all 3 of them. Jordo's is simpler. The other 2 are quite simple maps in comparison. They don't have as much spinning wheels in the background. But because they didn't have that problem with crunch as much, because they didn't have as much problem with scoping and time limits, they were all stronger maps than ours, because they all had an idea and they executed on it to completion in the 8 weeks. So, now I've basically drilled into your heads stuff you probably already know. I want to talk about player direction. This is something which is the dark arts of game design. We have people at my job, we have people I've known, there are indie devs here, there are indie devs everywhere that have run slap bang into the stupid player situation. My players are stupid because I haven't told them how to play the game yet. I have no idea how to teach them how to play the game. And basically, it all comes back down to that magical word playtest. You can't make a game without telling it to making other people play it. And this is why game design is hard, because if your game isn't finished, and the feedback is game not good because game not finished, you've basically wasted 2 hours of your life. And overall, it comes down to that scoping problem, and it comes down to how do you actually do playtests which are good enough to really give you the feedback you need to get a project done to completion. And I think there were a few mistakes we made in this project. I think the first one, the biggest one probably, is the fact we only had 2 people on the project, and we didn't really sit down properly with more experienced world devs and go through it. There's like 200 people on Prefabs, and I didn't really workshop this with anyone other than myself, Flower, and a few, like Socks was there a couple of times, Senpai had some ideas. And it wasn't really a good use of many people's knowledge. Special shout out, by the way, to Luke Dooley, who's not here tonight. He has been incalculably valuable on this project from a personal feedback to me perspective. And most of it was quite blunt advice, and it really, really helped out later on, particularly after Spookality. But that kind of feedback is critical. Something the Valorant team did, regular playtests. They did it. I didn't do it as much for this project. When I was running the playtests, I was like a couple of playtests towards the end of October. Oh god, everything's terrible. Fix. Don't do that. And I should know this, because I do Agile at work, and we work in 2-week sprints. Why did I try and do an 8-week one? I don't know. So some stuff comes back down to that problem. When you don't do playtests, you don't realise how stupid your players are. Which means that when you're telling people, to give you an idea, when you start as the murderer, all you have to do is run around and hit people with those scissors. Very simple, quite dull goal. If you're a survivor, you have to go get the green key to open the safe, to go to the ritual room, to go figure out what items you need, to go find all 4 items, which out of the 6 that are in the world, put them in the ritual room, activate the ritual, take the free fuel cans that are scattered around the world, go downstairs, put the free fuel cans in the generator, go get the red key, which is scattered somewhere else in the world, bring it down to the generator, use the generator, then go up to the front and hit the button to open the front door to escape. Yeah. Design. We should have seen that coming, and I didn't, and I feel like that's kind of an obvious thing. But when you say it like that, basically. Player direction is hard, and when you don't understand that, you'll make really, really stupid mistakes. I did 2 things after the launch of this project, once Spookality has been done, to try and fix this, and I'm pretty happy with both of them. The Murderer, for example, now has a speed-up mechanic. Murderer hits somebody, they get rewarded, they actually move faster, because the Murderer normally starts off being slower than the players, and every time they kill somebody, they get a little bit faster. This also helps the whole problem of rounds taking ages, because basically if the team fails to avoid the Murderer, they're going to lose, so just make them lose faster, it's more fun for everybody. We should have known that a few weeks earlier, but we didn't do enough playtesting. I needed to see how the world was working first. The other of those being, I ended up assigning literally a quest log to everyone's menus. It's not great, it's on the headset rather than the hands right now. That is being fixed next patch. But it's basically you need to do this. When you're starting to throw, here's your to-do list onto game design, we're not making an MMORPG, we're making a fun 10-minute experience with your friends, and it begins to sound like a bit more of a chore than a game. And again, this comes back down to those fundamental game design decisions and how you can't fix them with we'll fix it in post UI decisions. I don't think there's a problem there in terms of people can play and understand the world without me there to direct them now, but it's not ideal, and I'd rather have probably stripped down at least one of those features, like just get rid of the generator completely, or get rid of the ritual completely and make everything about the generator. That would have helped a lot on this project. Never, ever, ever overscope your project. It kills it. I think also there's something said about map design. This is also a dark art. There's somebody, you talk to a level designer, someone who's done Team Fortress 2 maps or something, and they start talking in esoteric words about player direction as if it's almost like a fluid. They talk about flow. They talk about shapes of doorways. Is a doorway important or not? Well, if you make the doorway bigger, it's more important than a smaller doorway. If you make the doorway archway to more detail, it's also more important than the minor doorway in the back. Something that throws people in VRChat maps often is high detail asset is completely useless. Crappy low detail box cut door is somehow the one you're supposed to go through. It's stuff like that. And it's weird, but players are stupid. They're always going to be stupid, and you have to do loads of tricks to make them not be stupid. And they get back onto, people don't know how to play this game. And you get all these problems coming up. So, I think there's a lot of things we've done with the map design to make it better. Murder's a good example of Murder 2 is a good example of a packed together map, as is Slaughterhouse 1. There's only a few corridors. You can basically figure out the routing of the map in 5 minutes. You know what the role of each room is in Murder 2. You know this is just a room to explore in. There's very few decisions you actually make in Murder 2 when you think about it. It's you go riffle through looking for the gun, the clues so you can get the gun, or you are the detective, or you're the murderer. That's pretty much all you do in that game. And this is where that sort of art and music and design and stuff comes in, right? Because when you start talking about map design, you can grey box it. You can think it looks good in grey box, and to be blunt, Slaughterhouse 2 is still a grey box with colours, and very performant colours, but it is a grey box with colours. It's big, ugly boxes that don't sell people on what the role of a room is, and that's when prefabs and map design and audio and textures, that's when that comes in. But remember, if you make a layout of a map which makes no sense and then fill it with beautiful assets, your players are still going to have no fun in it and they won't visit the map again. Whereas Among Us, the PC game, isn't the most graphically complicated thing in the world. Because the design is tight, people come back, and because the graphics do enough. Remember that John Carmack wrote, choice about 500 smart decisions. Good enough. And that's where you're like the best person on your project in the game design. If you're like doing like 100 people on the games team, I got annoyed. A director once got very cross with me for saying this. The most important person in your team is the producer. Anybody else on the team gets hit by a bus, you can hire that person. You can rehire that person. Even your game director. If the producer gets hit, nobody knows how they made the Excel spreadsheets. That is a human decision that they have made. The planner, the person who organized this stuff, is your friend. And if you end up with a project with, say, I don't know, Cyan, Lakuza, all four of the ponies, for example, are great at this, from what I've seen. People who plan, organize, know what their time boxes are for stuff, how long stuff takes, they are invaluable. If someone, and Bagel's a great example, he's not here today, little Bagel, talk to him about like charts and like time boxes for things, and spend a couple of hours doing that. I want to talk a bit about also, this feeds back into the design. Slaughterhouse 1 is made by, I think, more educated level designer than us two. And it was made by a person called Minitoon with help from somebody else. And that was for Roblox. It's an incredibly popular map on Roblox. It's got like 15 million plays. And that map is also pretty basic. It doesn't have particularly complicated textures because it's a Roblox game. Have you seen what that game looks like? But it's incredibly popular because it has a recognizable thing. It's just a residential house in an American neighborhood, and it just goes, well, it's got a bathroom, it's got a kitchen, it's got a dining room, it's got a couple of other incidental rooms, it's got a couple of closets, it's got a bedroom, and it's got an attic, and people get that because it's familiar but different. The way I don't think our map quite succeeded at in the same way. Also, that map does an amazing job of verticality. Take a look at that map if you can. Just go on to like Slaughterhouse 1, which is on my account, with an alt, and just take a look at how that verticality that map makes sense, and then figure out, oh wait, so if the murderer, every time you go down to the basement, you're basically screwing yourself over unless certain things have happened, and then you go further down to the basement and you're even more screwed over. So as soon as you make a decision to drop down in that world, you're getting more and more and more tense. That's a really strong game design. And it's such a simple thing for a Roblox map that I was honestly stunned at the time when I figured it out, and I tried to emulate it for Slaughterhouse 2, and I don't think we were successful. I mean, we did a good job ripping off the Devouring's water mechanic, and yeah, that was quite fun when the ponies saw that, and they're like, wait a second. I was like, look, it was an accidental rip-off, but it's totally a tribute now. Also, something else. Sometimes your entire game design is just slightly wrong, and I think this is a good example of Slaughterhouse 2 versus, say, the Piggy series. In the Piggy series, there's like 4 different game modes, and one of those is the most popular. When you watch like streams of this game or whatever, you'll see the player versus AI mode. The AI in that game is cartoonishly stupid. It's a Roblox AI. It just sort of follows around in bad nav meshes, and most of the time the players are just laughing about how bad it is. But because nobody's playing as it, everyone can mostly focus on the objective, so they know how the map works better. Because the AI is so bad, it's just a little bit of safe tension. And then they're able to figure out the puzzles and how to sort of escape the map, and then they'll play the more complicated maps. When I do Slaughterhouse 3, which will be late next year probably, it will be like that. Don't associate, oh, you know, players love running around killing their friends with, this is good for the project. Because when you're doing like a puzzle map, almost, with this kind of stuff, people hate doing puzzles under pressure. They hate it. It's the worst thing in the world. There's a reason why Keep Talking, Nobody Explodes is so funny to watch. Because that game is puzzle under pressure, and people screw up and it's entertaining, whereas in Slaughterhouse 2, it's often quite frustrating. So I want to talk about a couple of key learning slides on this before I go on to Udon. Overall, I think the project was overscoped in terms of design. We didn't test early enough. I think the world was somewhat lopsided. If we'd had more art resource to time, but that we didn't, that we probably would have done a lot better at the project. It would probably also have been, if I'd been spending more time doing art, I would have probably not done as much code, which is probably more fun for the project and overall stronger. We also consider stuff like music and sound effects far too late. The best thing, individual best thing in the world right now is Modex's music, which is a couple of tracks from Modex, which is Friend of Flower of Goods, and they're fantastic. He does it stuff on Newgrounds, go check him out. And we added that music in after Spookality, and I felt terrible, because adding a bit of appropriate music transformed the game experience in a way I did not understand till this project. Music is so important for getting an emotional response out of people and making it more fun. And I definitely learned that on this project. Every other project from now on I work on is going to have the music as like the second or third thing I think about. What do I want people to feel like? Let's go do some research into the music, which is what Flower does for his avatars, by the way, and go start from there. Because as soon as you hear a piece of music, you are inspired to do something, and you can get the theming down. You can teach players, is this a stressful situation? Devouring is a great example of this with the safe room, peaceful music. Rest of the mansion, horror. Safe area, safe music. And I think with more people and more money and more time, this is easier, but with 2 people for 8 weeks in a project, it's impossible to balance design, code, and art. Particularly when you don't take shortcuts like using prefabs. So, and like I said, the project wasn't bus safe essentially. And I could have relied on good asset store prefabs for, shortcuts, for making the world look good with a budget, but I didn't. We didn't put music in until very late on the project, when I should have done. And what we ended up having was this lengthy crunch period, particularly personally, where it just didn't produce a good map. And it comes down to that lack of time and some aspects of design which are unfortunate that really killed that project. In terms of like being the top tier kind of map. Like I can really bad remembering Jordan's map, but Jordan's map's a great example of getting everything done on a project in like a small way, but still making a fun map. And I think the whole thing this comes back to is something I should have known. I work in Agile. I've worked in Agile. I'm a Scrum Master at work, I would like to be. I have the training, and these 8-week iterative projects are completely insane. Don't do them. Like, if you can release something in 2 weeks, go for it. Like, Polygonal Mind's a great example of this. He released like an avatar each day or something daft, like an avatar a week. Look how much work he got done in a year, right? And if you're working on these giant projects, yeah, the devouring worked out, but you've not been doing Udon or SDK2 for 3 years. You're not like Cyan, who sort of apparently lives and breathes the code inside their brain, right? You're not like, if you haven't got that experience, this stuff's harder, and it just ended up being a lot of silly compromises we made. And finally, I think, like I said, I'll probably start off with something a bit more fun, like a player versus AI mode next time, also to give myself a break from the same repetitive gameplay context I've been living in for 6 months. So, that was a lot of talking about game design from someone who isn't technically a game designer. Like, I care about it a lot. It's a really interesting topic, and there's some fantastic books and literature, but it's been definitely a hell of a lot of work for me to learn this stuff, and I don't think I've succeeded yet, but I will do it on my next project. And I want to talk about 30 minutes. Like I said, you people have to listen to me. I pity you. I'm going to talk about Udon, because that's kind of my thing. When I started off in prefabs, I was an Udon guy. I didn't make a map until, like 3 months after I joined. I wrote Udon Sharp. I did Udon Sharp stuff, Udon Chat, and some event-based bus systems and all that kind of thing. Udon, I'm a coder. I love code. It's my favorite thing to do in life. I get to do it for a living. I recommend it. If you do something you love for a living, it doesn't feel like a job. Everyone thinks that's BS, but it actually is true. And I'm going to talk a bit about Udon, and I'm not going to be very pleased or polite about this, because when you work in Udon for several months, you sort of get a bit sick of some of the things in it. So this is stuff currently wrong with Udon in terms of networking. Sync variables are dreadful. You basically don't use them on projects. If you do, you are stupid. There are better ways of doing this. It will make your project explode. Everybody will complain, and you'll tear your hair out at 3 o'clock in the morning because it looked fine with 2 people, and you had 5 people, and things went horribly wrong. So the main reason for this is that as soon as you add any synced pickup, any synced variable into your world, you're increasing network load. It's doing nothing. It's completely fine. It isn't. It's continually spamming the internet saying, I am not doing anything. To the point where you basically crash your world doing this. There were some examples of Luke Dooley's map, Shattered World 1, where we'd load into the world. He had like a few synced R's at that point, only a few, with the zombies and stuff. And the world just crashed. The relay server went over. It's supposed to be, in games, this kind of replication stuff is like core. It's beautiful. It just works for guaranteed events and stuff being sent over. In VRChat, it's really, really bad right now. Which is one of the core things why these maps are so rare. Like, people don't make in Udon like repeatable game maps and stuff right now. They're doing much smaller things, because as soon as they run into networking, it's like bounce clean off. Even people who do this stuff for a living struggle with it. Keep that in mind. Custom network events are the solution. They're incredibly bad because there's two kinds. You can send it to the owner of the object. You can send it to everybody. And you just say this. You can't say what this is at runtime. It's just something. Which is beautiful, because it's a bit like saying, I need to know exactly what everybody will ever do in my world at all times without having any sort of contextual notion of this, which means your brain has to go from being this big to like this big just to get stuff done, which is quite frustrating. And the problem with events is they're fallible and not synced and all of this kind of thing. And as soon as you tell people, well, what happens if you tell like a newbie to this stuff, oh, what happens when somebody joins my world afterwards? You sort of go, ah, yes, young Padawan. You're screwed, mate. Sorry. You're gonna have to figure out how to manage this yourself, because events are fallible. And also, events aren't guaranteed to be delivered. Sometimes they'll drop, and then your world breaks, and you're sad. We get all these compromises and caveats with Udon right now. However, there are some clever tricks with it. I think it's fair to say that the custom network events in Udon are going to be around forever. They're useful. They work sort of right now. They're the only thing in Udon that properly works to how we'd expect it to do as network engineers. But oh boy. They are having an entire system based on fallible events is hell, to be blunt. Hard to replicate bugs that happen when the world's at load and stuff explodes, and you go, it's VRChat, we can't do anything. It's why Cyan Laser yesterday said, yeah, SDK2 is going to stick around for ages. If the networking stays like this, I can definitely see why. Ownership is another mostly working system. It's basically Photon's ownership system, except it doesn't sometimes work, except you have to know how the ownership system works, except you have to remember how stuff transfers between people, and you sometimes have tricky stuff figuring out how this works, and then you have to remember this at runtime when you see bugs, because you're seeing, why is the murder weapon sitting in the opposite room halfway across the map when it's supposed to be owned by somebody? And it turns out that they ran into a crashed Udon behavior, and it broke, because they tried to collide with something that didn't exist, and there was a null reference check, and stuff explodes. Which is a pretty continual thing with Udon these days, at the moment. So, there's mitigations for this. At work, we use RPCs a lot. RPCs are remote procedure calls, and that's basically what a custom network event is these days. And overall, you have to remember with network events right now that you're talking about an owner event and an all event. This is annoying. This ends up being you have to know this stuff and keep it in your mind, but for people who've done it for a while, it's not too bad. So you can sort of architect a network model based on this. This is the boring bit of the talk. If I see people like crashing, like you can conveniently like pretend to be crashed if this bores you, but overall, we have a notion of game state, right? Game state is anything that happens in the world. You open a door, game state, door open to everybody. There are 5 people playing the game. That's game state. There's 4 people playing the game state. The murderer is Joe Bloggs, game state. 2 pints of fuel have been put into the generator, game state. All this stuff is state, which we have to manage. So you think about that in terms of, if you were like building a scale model of your world, like you try and replicate all these things inside the scale model for accuracy, right? If you're being really nerdy, a domain model, a principled representation of the world is a model of it. And we think about that when we start thinking about networking for a world. What are we trying to do here? What are we trying to achieve? What are the principal decisions that need to be made to get this world to work? What is optional? What is fallible? How do people make decisions based upon this? How does a computer make a decision based upon this? You do that by thinking first about what you want to get done and how you're going to encapsulate how that works easily inside a small number of classes or Udon behaviors. If you can do that, the rest of the projects, the rest of the problems are somewhat easy. If you are somebody who doesn't think about this early, you end up with spaghetti code. You might think your code looks wonderful. Try and get somebody to understand how it works. They have no idea. Hence why you need to think about that first. What do I want to achieve here? Where is it going to live? And how do I make it change? Who decides that it changes? And how do I tell people it's changed? So, on that latter point, how do we tell people it's changed? We need something called a view, right? You need to know something's changed. You need to get a document through the post telling you what your bank statement is. That's a view on your bank statement. How does somebody know that you've opened a door? Well, they see the door is opened. How do they get told the door is opened? Maybe by an RPC, a custom event, maybe via a things variable. That will still do the same thing. We want to represent what the internal model is saying, this door has been opened, and tell people, everybody, the door's been opened. But the key thing is the domain model is not the view. They are two different things. Because you need to have one person in your world, generally, make a decision about if something is a valid thing to happen or not. I have 2 fuel cans. Somebody adds a 3rd fuel can, the fuel can number goes to 3. If somebody tries and adds 2 fuel cans to the situation, something has gone wrong because there should only be 3 fuel cans. Somebody has to make that decision. And that's why RPCs and these network events where you can send to an owner are so useful. Because your owner makes the decision on what's going to happen, and you explain that decision to everybody else. The owner has to do that. They have to make a view of this thing that's happened, this event, this domain event, and tell people what's happened. So, last of that, we've made a we know there's an actor, somebody wants to do something. We know that we have a way of doing things which sort of encapsulates how our world works. We know that the player can see, or a computer can see what's happened. Well, how do they interact with it? You have a controller, a lever somebody can pull to try and affect the model. The key thing being, they're not trying to affect the view. That's abstracted away from them. They don't care what the view is. They don't have any knowledge about what the internal state of the system is. They only know what that lever is. That lever exists. It adds a fuel pot. It adds a fuel can to the generator. That's it. This is pretty classical. If anybody here is an engineer, it's MVC. It's Model View Controller. This pattern has existed in the industry for 40 years, and it's been superseded. I work in hexagonal architecture these days, but for games, particularly in Udon, particularly with the way we have to do things right now, it is the most elegant way we have to solve this problem of how do people figure out what has happened? How do people make decisions based on what's happened? How do people affect what they'd like to happen? How do we have somebody control how that happens? And how do we let people know again that that thing has succeeded or failed? That loop requires MVC in Udon right now. Hopefully we'll get the network patch through and there'll be some additional fun things we can do with Vue, and hopefully with actually making controllers better. At the moment, the model's fine. Controllers can be tough. The Vue can be an absolute nightmare. So, I have 20 minutes, so I'm going to try and blast through some of this stuff because this starts getting dry. An example would be, by the way, I'll make the slides available afterwards. I'm not going to try and read them on now. You have somebody up here, happy smiley face, who wants to add a ritual item to a pedestal. We say, well, that's happened. On the player's screen, they've placed it on the pedestal. On trigger, enter. The pedestal goes, hey, I've just had an item placed upon me. I need to go tell the ritual to do that. Okay, the ritual now has a decision being made. So this gets sent over the internet, or it can be in the case of item placement, that's already being replicated, so we don't have to worry too much about this. It's the same for everyone. But say it isn't. For example, if the pickups aren't synced. So it tells the owner of the ritual, hey, something has been placed upon this pedestal. Do something. So the ritual will try and figure out, well, which one's been placed. We can do some ownership and networking event stuff to do that. You can tell, for example, who owns the object. You can send a message to itself saying, hey, the owner of this object has done something, and everyone can check the ownership of the object to figure out what's happened. You can do some fun stuff with that. But basically, you get to the point of the ritual has to figure out, is this a valid item? And how many items do I have upon me right now which are valid? How many invalid items do I have on me which are valid? Because you can have multiple items on these pedestals to make the ritual work. And it'll make a decision. The owner of the ritual makes a decision. This is a valid item. You've placed the eggs, and we need the eggs for this project. We need the eggs to get the ritual working. So it will then tell itself in the code, but really it's a separate concept. It will then tell everyone else that the ritual has succeeded in adding an item to the ritual. It's that simple, because at that point, everybody can see, or the computer, maybe its internal state or its external state, we've exposed it to the eyeballs of the actor, the person playing the game. We've said, oh, hey, this ritual has now been added to, it's now in state. We can state it's happened. This works for games. This works for pretty much any VRChat map in Udon right now. Is this simple pattern. I want to do something. Somebody makes a decision on how to do it. That person says it succeeds or fails, and we update our local state, what we're saying on our screen to match what that person decided on their screen. One nice thing about this, by the way, is that you always have your decisions made separate from how you tell people about these decisions, which is actually useful still in single-player maps, because it's much, much more modular. It needs to swap things out. You have your business rules, your invariants, your decisions about how the game works, in a different area to how you actually tell people about it, which means you can work on some stuff over here without breaking your complicated game logic. It's quite nice. Very, very good pattern to get into. And I've got 15 minutes, so when starting out with Udon, Udon Sharp is particularly very easy to forget what little tricks you can do. Set program variable, get program variable, send custom event. If you define this properly, it's basically an interface. You can just say, I know that anything I want to interact with this pickup is going to be, if it enters a zone, I'm going to get stuff put on my pickup, which is telling me kind of what I can do. You can do some really clever stuff with this. Again, I'll share these slides later. I'm actually running out of time. Custom interfaces. You can also use it as callbacks, using some engineering terms. You can say, oh, the hammer has entered the area where it's possible to smash things. Now, I'm going to do, when I do on pickup use down, I'm going to say, oh, this thing's been smashed. I can smash things now. If I go into a separate area, you might be able to do something else different with the same pickup, the same code. And all you've done is use some set program variable or something else to affect the pickup. So it's basically an interface. The pickup doesn't know what it's going to be interacting with. It just can interact with something. This is something I'd be able to talk about an entire talk about, but it's very complicated, boring, and esoteric, so I won't do so right now. There's also fun things you can do with a lot of random weird things in Udon. Rigid Body is a great example of this. I pretty much figured this out a few weeks back. For some reason, we've got access to Rigid Body Sleep and Wake, which is really handy for syncing pickups and fixing stupid problems with pickups. But again, I haven't really got enough time to go through that stuff. One thing I'd also recommend, which is normally something I typically avoid in my code, but it's inevitable in Udon, write one main game controller area of your world. Try and keep all of your Udon code, which is like, the world has to work kind of like this, and it kind of has to do these steps, and everything kind of has to know about everything else. If you've got that situation, don't put it in multiple Udon behaviors. Put it in one. It's more performant. It's way easier to understand. If you document it properly, it will break less. It's also, like, just generally easier to write. So, for example, in Slaughterhouse 2 and 1, there's a game state manager class. That's the domain model for the entire, like, game state. Like, who's playing the game, how many pieces of fuel have been added to the generator, who's died, that kind of thing. How many players are, is the door, exit door unlockable or something like that. That's all done inside one class. You do it that way because that means you don't have to jump between so many different contexts of, like, what am I doing? Like, this ritual system is like this, and then this, like, generator's like this, and then there's the main login code and all this kind of stuff. Try and keep it down to something simple you can skim through. If your class is getting like 3,000 or 4,000 lines, maybe you want to break it out. But generally speaking, this kind of singleton pattern is unavoidable in Udon, which gets onto the fun Udon stuff we've got limits with. And generally speaking, try and architect based on having useful controllers affecting specific models or update views. Model, view, controller. Much easier than trying to keep stuff inside the same class. If your class is a lever or a button, don't write the same button class 25 times. Just write a generic button. There's a script up there called activate udon behavior.cs. All that does is basically a bunch of scripts I can just produce. Like, this is a generic thing which does something, and when this is triggered, it does this. That saved me so much time in this project, because once you have something that's common like that, you don't have to worry about how a button works anymore. You just throw the same thing on everything. Try and optimize your workload like that. Now, got 15 minutes. I would like to have some questions. Let's try and get through this. Some cool features. Object ownership, mentioned that. Big generic doer, I've mentioned that. Anti-cheat systems. As soon as you start making games in Udon, somebody's going to show up with a chair. Ever had that in one of your worlds? So again, the devouring people mentioned yesterday, Simon mentioned yesterday, is chairs and people being outside the world via play space. Think about this stuff. You might not care, your friends might not care, but there's going to be some absolute sod of a brush avatar that shows up in your world with some kind of abusive VRChat feature, and they're going to make someone's life miserable. Your job as a game developer is to make sure people do not have misery playing your game. Try and think about this stuff. It really helped with this project, I think. Our current the Slaughterhouse 2 is very hard to currently break. It's doable, but it's not going to be a case of I throw a chair out, I warp into the map while it's running, I run around annoying people. That kicks you back to the spawn area. Also, there's some stuff with teleporting sync pickups. This is going to not matter in a few months when we get the networking through. Talk to me if you need this. I'll happily tell people how to do this. Sync pickups being teleported around don't technically work right now, but you can hack Rigid Bodies to make them work via Rigid Body Sleep. A lot of stuff we learned in this project, and that's the thing about these kind of projects. You'll learn stuff and it becomes useful. You can't, like, go from 0 to 60 on any project. You couldn't have made the 4 ponies couldn't have made devouring if they hadn't done, like, side hand and archery first, right? That doesn't happen. Try and standardize on code on projects, just please. Try and also write how Unity writes. I get sick of seeing, like, really weird, like, personal choices on code. It's really hard to audit. VRCon's been a lot like that. If you need everything resettable, keep the names consistent. Call everything, oh, I need this to reset. Reset it. Just call it reset. Don't call it fix X, Y, or Z. Just call it reset. Just keep things simple. You will thank yourself so much in the future. So you want to pull up on this slide. Complexity is always bad. So if there's a situation where you feel like, well, I should do this, but it'll be really hard, it's always fine to break it if it makes it simpler. Like, you could break the whole MVC thing and like muck around with stuff outside that model if it makes it less complex. Don't try and overcomplicate your project, because that's overscope and it will kill your project, like I said earlier. Also, finally, this is something if you take one thing away from this talk, go install this. Stop using Git LFS. Stop using Unity Collab. Stop using anything else. Maybe use Perforce if you're loaded. Plastic SCM is the best individual thing we did in Slaughterhouse 2. It's basically a source control system, which is fast, which works, which is easy for artists to understand, and has 5 gigabytes and free user licenses completely free. You can just back your avatars up on this system right now, and it's great. I will talk about this in another talk sometime, particularly about why Plastic's great. Just go check it out on your next project. It's owned by Unity now. It is the best source control system I've used for game dev. It just works, and it's really smart because you don't have to teach people how to do stuff, because it's got glue on, which is like an API, like a simplified system for it, which is fantastic for people who don't give a toss about how source control systems work. They just need to put their nice models in a folder somewhere, hit a button, and then go have a kebab. I really want to see people use this. I know Vogan's been talking about this stuff. I know this has been slowly creeping in. Please, please, please take a look at it. It is going to save you so much time on your projects, and it's free, and it's licenses and space for free. Just use it. I'm going to try and wrap up now. Udon's really slow. Udon is really fragile. If anything crashes in your Udon code, it's permanently broken until someone reloads the world. It's really bad. Keep that in mind. This stuff isn't improved, but right now, it's the stuff we always learn in these projects. Udon is always worse than you think it will be. Udon is always more fragile than you think it will be. Udon's networking is going to throw you under a bus at any time it can. Anything that's deeply complicated, like, I don't know, an AI controller, it's going to be a case of, if you know how to do it in SDK2, it's going to be better in SDK2 right now, because it's all like Unity hacks and stuff that Unity's tested rather than VRChat. So we're in a weird situation with that right now. Noir and Submerge 2 show that you can do really good adventure maps inside Udon right now. But if I was doing sort of, I don't know, Murder 2, I would probably go and check out like how to do this hacky stuff in SDK2, because it won't just crash and ruin somebody's day. Remember Carmack and Miyamoto's quotes from earlier. Try and keep those in your mantra when you're talking about doing game design or big projects in VRChat. Keep things simple. Make smart decisions. Don't put yourself into a case of like, I need to be brilliant on this. Just make intelligent scoping decisions and figure out what your budget and your time is, and make sure that if you can delay, that's always fine. But if you can't delay, never ever overscope your project. So personally, I'm going to be looking at basically making all the same mistakes again, but smarter in my next project. I'm working on something called Between Uncertain Stars. It's basically everything I've learned from networking in Udon, improving, basically. It'll be a lot less buggy. All those kind of caveats of your next project's always a really good one. But I'm hoping to wait on the next networking update for Udon before I start this, because I'm pretty sick of the current one to a point, as you might have heard my voice in this talk. When I make Slaughterhouse 3, I'm not going to do it with 1 or 2 people again. That was too stressful. I'll do it with like 3 or 4 people. It'll use a bunch of prefabs. We'll get the music done in early. We'll do a whole bunch of playtests, and we'll try and release a small internal build every couple of weeks. Those are the core learnings in this project, and I'll try and implement them. I think Jar proves that the kind of project I'm interested in doing in VRChat, which is kind of like social, strategic, like one person versus a bunch of people kind of games. Murder 2 is successful. Murder 4 looks to be successful. And of course Among Us, the map is incredibly successful, and they work on that model. I think they're successful. I think there's a scope for like getting that better in this kind of thing. I'm looking forward to seeing if I can do that in some sort of more weird designed maps, and see if we can get that done. And basically, yeah, I just want to wrap up now. I've got 10 minutes left for questions. I want to say a big thank you to everybody for listening. I appreciate I'm not the best speaker, and I do talk too quickly, so I do apologize for that. If anyone missed anything on this talk, it's going to be recorded. You can slow it down and check through stuff, or directly DM me on Prefabs to get information on this. And I'll just leave us our socials. I'm FairlySadPanda on Twitter. Flower Good, invaluable in this project, the best person ever. He's at Flower Good Yes on Twitter. I encourage you to check out Slaughterhouse 2 and its predecessor Slaughterhouse 1 if you're interested in game design. If you have any comments or any feedback on it, some stuff you didn't like, some stuff you did like, bugs, that kind of thing, just get in touch. I will fix them. This Slaughterhouse 2 is not done. That's why this isn't a post-mortem. It's a retrospective. And also, thanks also for you being the best bunch of people on the planet. Like, seriously. Most game dev communities are cancerous, competitive, awful. Like, I need to be the very best, or they never get anything done. I don't know how you guys do it. You're amazing, seriously. I mean, I've had a hell of a month, hell of a year, but you're all awesome. You made my entire lockdown experience genuinely, like, very, very positive. A lot of people that are hurting right now. I feel genuinely fortunate to be in this community. So thank you for your time, and I'll just open this up for the next 5 minutes for questions. Apologies, I know I've basically done a lot here, but questions over there, otherwise my voice is firmly run out. Thank you for your time. I didn't think this would be in a whole hour. I forget how much there is. 31 slides. All right.
Well done.
Okay.
Yeah. Thanks so much for your talk. I was wondering, like, you have a drafted sort of version of the networking guide, which was like floating around. I don't remember if it was ever put in the database, but I was wondering if you were planning to, like, you put a lot of stuff on these slides. Which is great, and the slides will be attached and be on the website afterwards with the VOD if people want to watch that. But I was wondering if you're planning to do something more comprehensive and maybe aimed at people who are just coming into Udon, or are you going to wait for the networking update for that?
I've been stuck on that ever since. I've been stuck on that ever since we learned about there being a major network overhaul from Dan Leebot at some point in the next few months. To give you an idea, pretty much everything on this talk about networking is a placeholder for a vastly superior system we're getting. I'll just quickly touch on that now. We're getting the ability to have reliable, low problematic situation synced variables that can store a lot of data. And once we have that, all of my problems with sort of Udon stability, particularly with netcode, go away. Particularly with buffering, we just get it's just a better model, a better system. When we get that done, I'll be doing a full like video or document guide in it, like full screenshots and explanation. Try and dump everything I know about network models and code and stuff into one document. The main problem ends up just being it's just that scoping problem, and people have so many different things. Pika Pete's a great example. He came onto a voice call a while back and said, "Hey, I've got this problem," and I'd been spending months doing network code this problem, and it's like, how do I explain this to somebody easily? Like, in a way, it's very tough. So I'll probably want to do a bunch of playtesting again and figure that stuff out. But yeah, sure, there'll be a bunch of documentation on this hopefully next year once Danley gets the netcode patch out.
Okay. Thank you. Thank you so much.
Right. Oh, dear. Anyone else any questions, or I can go get a drink of water? Hello, table. Hello, table.
Honestly, I'm sorry. Hey, I'm honestly sorry I never really asked this before. The synced variable thing, does that apply to pickups too? Just any sync thing at all? Shit.
Not as much. Sync pickups are a lot better because they're sort of an SDK2 thing that's been put in SDK3. They're a lot better, but they still like add network load. Sync pickups can be really like a lot of them, particularly with network collisions and like physics. That's why people crash at community meetups. Is like, I put 50. This thing happened which I didn't know about. You figure this out and it's like, this is weird, and you find something else which is weird. Cyan mentioned this yesterday with the whole like switching off like triggers for like slowing the player down doesn't actually trigger on player trigger exit or whatever. It's like stuff like that, it just kills you. It's so many gotchas and small things you have to keep inside your brain. Even with this community, it's a case of I learn stuff new every day with Udon. I'm like, why is it like this? And it's usually the answer is either VRChat haven't fixed it yet or Unity things. So you know. Alright. It is what it is. It's pretty much like, I mean, we're all developing like free video games and social experiences on a platform without paying for it. On a platform which isn't really supposed to be doing this kind of thing at scale, on a platform which was built 7 years ago, on a platform that the devs don't have access to source code on. Like, it's a miracle this works at all. Our computers should be burning down. We should have all died by now from smoke inhalation, you know. So yeah. Anyone else? Okay, go grab a glass of water. All right.
Okay.
If you ever, anyone else? Just hit me up on Discord if you've got any questions.
Okay, thank you all so much and thank you FSP for this amazing talk. Honestly, I didn't expect it to go in so many things, but Hey, it did. So yeah, the slides will be up later after this whole thing, and I'll do a ping. But now we will take, I think, a 5-minute break, and we'll be back and with Varneon about learning, like starting the world development. So we'll kind of break a bit from like all of this details, networking and stuff. So next talk should be like the best for if you have a friend that's about to get into world development. That would be the thing to share. But yeah, we're gonna take a break, and we'll come back soon.
You did a good job.
Good job.
Okay, can everybody hear me well? Awesome. Let me just place my notes right here. Okay, so this is going to be an interesting one. I'm personally feeling a slight pressure because we have seen some amazing talks right here, and I'm basically going to be touching on every single topic almost that we have heard so far. And yeah, this is just going to be touching on general learning process, like how you should view some things, and kind of like just an overall overview on some of the skills that you might be acquiring, some of the tools, some of the resources that the community has created, and basically just giving you an insight. The presentation is kind of a weird mix between a tutorial and just an overall talk, but it's hopefully it's gonna be filling its purpose. It's truly a pleasure to be here, and I'm truly honored to be sharing the stage with so many talented creators. And it really warms my heart to see that we're able to have these kinds of experiences for free for all of us that we can share, and just building the metaverse together. VRChat. It's truly something revolutionary in my own perspective. It's completely free platform that allows us all to express ourselves in so many different ways. We have dancers, we have musicians, we have artists. Now we even have like photographers working with prefabs that have been kind of emulated in this virtual space. I'm going to mention Hirabiki. I'm probably pretty sure a lot of us have their prefab on our avatars. Just results in truly amazing shots that we can share with everyone. It's like a common media that everyone understands, even outside of VRChat. We have actors, we have actresses, just live performances, truly amazing. And then we have the creators. We have the avatar creators who are creating all the avatars that everyone can use, and to just personalize yourself and just kind of build that your virtual identity that you're going to be using throughout your days. And then we have the world creators. We wouldn't have the amazing worlds to go to without these people, and a lot of us here are creating worlds, and that's what we're talking about here. But I feel like world creation is one of the most important factors in shaping the metaverse, because it's the static environment that we're exploring together, and that is pretty much the world that we're creating here. But yeah, who am I, or who am I pretending to be? I am a world creator. That's how I like to classify myself at this current moment. I'm working on expanding. I'm working on YouTube videos, going through my development process, explaining some of my Udon projects, and just giving an insight into my workflow, etc. I'm next year going to be selling my own 3D models. I'm working on some model packs, like for nightclubs. I'm going to be showing some references in the next slide. And kind of just, I'm looking into making VRChat, everything related to VRChat, my full-time job, and it pretty much already is. Like, I just walked up to my boss and told him, like, this is something that I truly believe in. I want to dedicate all of my time towards this, and I just really want to catch the wave that we're on right now, and just bring this metaverse to a completely another level, where we have interactivity, like I'm mentioning on the bottom, that I'm specializing in, realism and interactivity. That's something that I'm truly passionate about. I started VRChat during the summer of 2018. I just got my first VR headset, HTC Vive, and I was instantly blown away by the immersion and I picked up Unity slowly, kind of just tried my own prototypes, just standalone game development. I'm a jack of all trades. I have never really settled down on anything. Like, I went from carpentry, I went through fire truck mechanic, mechanical engineering, pretty much creating CNC programs as a day job, and now I'm kind of just doing some mechanical engineering related work. And but now I'm not like, now I'm finally starting to find my true calling. Like, this is something that I'm truly passionate about. I kind of stopped talking about it seriously. I have no professional background on anything related to VRChat world creation. That's going to be disclaimer. Everything is self-taught. The only relatable thing is CAD modeling. I have about decades experience through Inventor, through SolidWorks for mechanical engineering and carpentry. So that's one point. And yeah, I think that's all of the important details about me. Here are some references for my 3D models. I'm using the workflow of Blender through Substance Painter, and then basically creating my own model packs internally that I'm then going to be using, or like pulling from my library into any one of my projects and uploading through that, or updating every single model every time there's a revision. And I just feel like I'm working on so many different things, and as one singular entity, I can only work on so many things. It's better for me to just give everyone the equal opportunity to make their own experiences as realistic as possible. So I kind of just want to be selling these forward, and so everyone can kind of enjoy them. Shameless plug, I'm going to be exhibiting at Virtual Market 5. I'm going to be showing my most popular prefab, the drivable vehicles that allows you to grab the steering wheel, grab the gear shifter, push the pedals with your feet, and you have working doors, stereos, audio muffling, dashboard, everything, all the good things. You should definitely check it out. I also have a list of prefabs that I'm going to be releasing on the menus, and some demos for my models. Basically, every single model that I use to build my Virtual Market 5 booth is going to go on sale, pretty much, except the car. So what I will be going through during this talk, I will be generally touching on what VRChat world creation is, and kind of how you should start, some general learning tips, and how to maintain your inspiration and motivation, and where to look for it if you don't have it. Some tools and resources, like a lot of the times you run into a situation where you're just listening to your friend, you're just asking them for tips and tricks, like where do I start, and they have their own source of knowledge, and you cannot really confirm that. So I kind of just wanted to have this presentation for some of the confirmed sources where you can actually go and look for this information for. I will be going through some asset acquisitions, downloading, purchasing, or creation, and then comparing game development, VRChat world development, Udon Sharp, and NodeGraph. I know a lot of people are going to hate me on that section, but it's going to be worth it, I think. And then what skills should you focus on? We have so many different things. We have audio design, we have 3D modeling, texturing, shaders, we have game design. Like, we can even have networking really soon, like FSP was mentioning. Like, it's completely another topic on its own. So we are basically going to that point, I believe, where we're having proper game development inside VRChat on this platform. So you're going to be seeing a bunch of different fields being utilized in just VRChat world development. And then some final notes and questions. I'm pretty sure this talk is going to be ending before the set time, so we're going to be fine. So what is VRChat world development? I just went to Miro and I just drew a little sketch. It's just basically you have you have your Unity editor. So VRChat is running on a game engine called Unity Engine. And Unity is providing an application that allows you to develop games for the Unity engine. And basically, in this scenario, we are using VRC SDK, the VRChat software development kit, that VRChat provides as like a plugin, which will provide us with the necessary world components. Like we have the world descriptor that will tell the VRChat servers about the information of your world. We have some prefabs like chairs, portals, everything like that. And it also contains an uploader, which then allows us to communicate with their servers and upload our Unity package to be used in VRChat. So basically, we have our assets that we're going to be acquiring via any methods we prefer, and we're going to be throwing them into our assets that are going to be kind of assembled in our Unity editor. And then we're going to be throwing in everything into our Unity scene, and then that scene will define our world, and that will be usable in VRChat. So basically, VRChat is a standalone game, which will be taking the Unity packages in the Unity scenes, and then we can access those scenes through joining worlds or going through portals. So that's kind of like the basic idea of what we're doing. So why would you want to start? There are a lot of motives why people would want to start world creation. We have money, we have fame, someone maybe wants to prove a point, prove their worth. A lot of us have just the general passion. We want to have a creative outlet to express ourselves. That's absolutely beautiful. But no matter what, we are at a time where we need talented world creators. Like we can see in this venue that we're experiencing right now was created by one man during 2 weeks, if I understood correctly. Correct me if I'm wrong. It's truly amazing. Like, we are living at a time where you have all the tools necessary to create all these experiences. Like, you can have $1 million studios, AAA titles, just working on anything, but like, you still have this possibility if you just have the enthusiasm, the passion to create, and you want everyone to just enjoy our time in this metaverse. So definitely, if you feel the itch for creating something, just definitely pay attention to my next slides on how to get started, and we're gonna have a great time. So starting out, one thing I cannot stress enough is just make sure you have one place where you're collecting all your worlds. Like, just make some space, reserve, just make sure that you're not going to be filling your hard drives, especially your C drive, with all your worlds. It's going to be taking a lot of space, especially textures. And also backing up your files. Like FSP mentioned, Plastic is one great way to back up online, and you can revision, you can collaborate. Really useful. Or you can just have an external hard drive. I personally prefer having external hard drive that is completely disconnected. I'm doing monthly backups, and I'm keeping the external hard drive in a fireproof safe, so I can be assured that it's going to be fine. Yeah, basically, our first step is to follow the official documentation. Please refer to the official documentation. These are provided by VRChat. You cannot go wrong with this. They tell you exactly what you need to look out for. They tell you about their systems, how it works, and tells you about their first steps that you need to complete in order to kind of go through the steps of creating your first world. So you'll be going through setting up the SDK. This will be really small text. I'm just showing you the screenshots from their documentation. So you will have You will have all the different steps installing Unity, creating a project, some disclaimers, what you shouldn't do. Again, you can go wrong. Creating your first world, you'll have setting up scene, creating spawn points, explaining about their components that are going to be utilized in your world. And at this stage, this is a huge note. When you're going to be asking someone for help, you're calling your friend on Discord, hey, how do I do this? Or you're joining a voice channel, you're asking anyone for help with your project. Most likely, they are going to be referring to these different terms like toolbar, hierarchy, project window, scene view, game view, asset store, inspector. Please, at least take a look at them and understand what the Unity editor is made out of. It's completely modular. You can move the windows, and every single panel has their own purpose. They're all doing their own different things. Like you have all the assets listed in your project window. You can have the scene view. You can preview everything from like a fly cam, and game view will be pretty much like the final view of the player. So this is just a simple note to make your experience with someone helping you a lot easier. A while ago, not too long ago, VRChat used to have manual approval for their worlds that were submitted. There was a massive sheet of worlds where you could see their IDs, their uploader, their world ID, everything, all the details. And sometimes you will see on the side, low effort. The documentation will tell you to upload something simple, just making sure that your systems work. But don't just let it stop here. Don't just drop in mirror, a chair, let's just change the skybox, and boom, I'm a world creator. Don't let it stop here. We have so many different amazing tools. You like, without paying a single penny, you can create amazing experiences. I'm telling you. And this is kind of like the next note after, well, during the upload process. You should be paying attention to this little button right here. What checking this box means after you press upload. Everyone will be able to see your world in Community Labs. Community Labs is the first step of moderation, community moderation. Everyone will have the chance to see your world in not so public view, but they still have the chance to check your world out and kind of just make sure it's actually okay for being public in VRChat. But this is something I cannot stress enough. You can only give the first impression once. After you upload your world and everyone will be able to see it, the word will spread. And the world will spread even more if your world is really bad. Sometimes people are even associating your name with the world. They are telling their friends like, hey, this guy made some really stupid world, let's just ignore all their worlds. This is nothing new. It's a social game. Everyone is talking. Everything is based on socializing, and you should just pay some attention to this, just for your own sake. So we have tested that our systems work. You can play the world. Nothing's crashing. Everything is looking good, and now you can continue. Now let's go through some general tips on how to approach the learning process of creating your own worlds. Read the documentation for Unity and VRChat. There is a lot of valuable information in these documentations that will help you through a lot of issues. when you're listening to other world creators, watching tutorials, listening to conference talks like we are right now, you will be hearing a lot of terms. And something I have personally proven to be working really well with learning something new is to just take these different keywords. I have presented some of the most important keywords in world creation in this slide, and I'm going to be giving you an example. Let's say someone is mentioning the word LOD. You stop right there. You go into your favorite search engine. You're searching the word Unity LOD or VRChat LOD, anything. And you will find level of detail. Level of detail means that you can have a 3D model that has different levels of qualities. You have something that is 1000 polys when you're really close. That means how many individual faces the model has to kind of like shape its details and whatnot. Then you might have another level at 500 polys when it's a little further. And then maybe 100 polys when it's really far away. And then it's being called like it's completely invisible when it's out of reach. Then you have something like texture compression. Really important detail. Textures are bloating your file sizes on your worlds. That's why most worlds are something like 100 to 400 megabytes. Profile your worlds. Profiler is a built-in Unity window that allows you to profile your everything that is happening. We had some, I don't remember who was the one who was giving a talk about a profiler. I think it was one. You should definitely utilize it. And then just kind of like general terms, SDK, like I already mentioned, Game Engine Unity, and prefabs. Prefabs, we are VRC prefabs. Prefab is Unity's own method of building multiple instances of something. Let's say I want to have a chair. That chair is going to be identical every single time I place it into a world. I can make it into a prefab. If I make some changes into that prefab, then that will be applied to every single one of these items that I'm multiplying into the world. So that's just my personal tip. And then just some general recommendations. Start small, get comfortable with the technology that you're working with. Just try things out. I'm personally not going to recommend you to start with your magnum opus right as you start. I personally made that mistake, and I'm still struggling after 2 years. Just start small and don't be afraid to fail. And also watch Unity game development tutorials. I'm kind of assuming that you're going to be using VRC SDK 3 when you're starting world creation, because now it has the UDAN available, and also we're just still in this transition from VRC SDK 2 into VRC SDK 3, and it's just now is a great time to just learn as we're making those improvements, so you can kind of learn at the same time what issues do we have currently. Listen to conference talks, GDC, Game Developers Conference, Unite, Unity's own conference, and TLX. Here we are. It's just, that has been working for me personally really well, just working on a Unity project and listening along on another screen, just watching the conference and listen to some professionals explain their really deep dives into how they optimize their games or just tackled some really deep issues with their games. Really helpful. And collaborate. There's a lot of world creators just like we are here right now, and everyone pretty much has the same goal. We all want to make everyone happy. We want to make new experiences for everyone. Find someone that you're sharing the common goals with, and just if you're having people with different backgrounds, if you have if you have a programmer, like For Ponies has been mentioned many times during this event. It's the perfect example. You have different people with different backgrounds, and they're all filling their own roles in the team. And that is leading to a completely different level of a result. But now I want to move into one of these topics. Why am I asking you to start small? How many times has someone messaged me on Discord screaming for help? They have no idea what they did. Everything is lagging. They did something that they didn't research, understand, almost even briefly. You can see some really extreme examples. If someone is familiar with Blender, every single orange pixel is one vertex. That is 1,000 by 1,000 UV sphere, 1 million polygons. Never do this. You have something like 60,000 draw calls. Have something like 12 billion triangles being rendered every single frame. And your console is just filled with warnings, information, and errors. This also could have been prevented with VR World Toolkit made by one. Inspiration and motivation. Find something that you're truly passionate about. Personally, when I was starting VRChat, the past summer, my favorite nightclub got closed, and I basically didn't have another same type of nightclub to go to anymore, and I was just looking for a different solution. And then I came across VR and VRChat, and I just started working on my own nightclub. Originally, that was just supposed to be a place for my friends and I to hang out and just have some fun. But why did all of that succeed? Now it's the third most popular nightclub in VRChat. Why did it succeed? Because I was truly passionate about every single detail I put into the world. I believed in my work. I had always dreamed about all of these different details. Throughout my life, I have dreamed about owning a nightclub. Throughout my life, I have been dreaming about having a lot more professional gear, like speakers, lights, trusses, anything. And virtual reality allows me to bring everything into life. It's not so much about, do I want to have them in real life just to do something, but to just experience it in any way. And virtual reality allows me to create these experiences with certain limitations, and I'm completely fine with that. But it's just, this allows me to do it, and I'm believing in my work. So just find something that you're truly passionate about. I'm passionate about interactivity, realism. I'm spending 4 days modeling and texturing some speakers with some really fine details. I'm texturing every single label, every single sticker, every single dent, every single scratch, all of the different sliders, all of the different plugs, like with the individual pins, because that's something that I'm truly passionate about. And just give yourself positive goals. Start small. See what works best. Just have something that you can start with. And also for inspiration, you should definitely check out ArtStation, Pixabay, Pinterest, Twitter, Reddit. You have so many different resources. The World Wide Web is far and wide. You have so many different sources that you wouldn't even believe. Just look out for anything. Now we're going to touch on some software, some applications that are going to be helping your life, some websites, and hopefully these will work for you as well, as they have been working for me. Pure Ref. It allows you to build canvases of images. You can have all your references in one massive canvas that you can scroll through, zoom in, zoom out. You can export it, import any kind of image from any kind of source you want. You can add notes, and you can just sort everything as you wish, and just have everything in one place. Really easy as you're collecting reference images from all these different sources. Now as you're getting more organized, you probably want to set up Trello or any kind of Kanban board. Just something that allows you to manage all of the different tasks, like 3D model this object, optimize this, this has an issue, it has to be fixed. And finally, at the end of the list, you have publish the world. It should be obvious at this point that we are here to help each other. I'm truly passionate about VRC Prefabs is doing here. Just looking out for the community, helping everyone else. And here I have collected some credible sources that you should be checking out. We have VR World Toolkit by One, who was giving a talk yesterday. We have CyanEmu, which now allows us to debug our worlds right within our Unity editor. Cyan, you beautiful human being right there. Give some credit. We have Udon Sharp, created by Merlin, also present here. Thank you. I want to personally thank you for making it possible for me to actually start a full-time job in VRChat. Udon Toolkit, made by Orals, the same person who made this venue. Also really useful. This is a little bit more advanced. I was originally a little hesitant to putting it here, but it's just, if you listen to Oral's talk about it, it's going to be understandable. You also have the official VRChat Discord server. There's a lot of people there. Constantly everyone is chatting about world creation and sharing their knowledge. This should be one of your first steps. VRChat also has their official forums that you should be checking out. Opened just recently. You have a lot of different topics on tips and tricks, commissions. You have just general knowledge about anything. Just check it out. And also VRC Prefabs has their own database, public for everyone. A lot of fantastic community created assets that are going to be helping you throughout your world creation process. You can use this to learn more, just how everyone else is doing things, or just if you're feeling too overwhelmed about adding something into your world, you can just utilize the community created content. That's what it's there for. Download Blender. It is a free, open source modeling software that is finally being accepted by the industry. If you have any kind of other preferences, then you're probably coming from a professional background and you already know what you're doing. But for everyone else, please note that you're probably going to be needing some kind of 3D modeling software at some point of your world creation. Nearly guaranteed. Now we have the tools. We are going to be needing some assets. Mainly, VRChat worlds are made out of 3D models. Textures that we're using to cover the models and paint its surface, give its characteristics visually. It is not just a gray model. It has color, it has depth, it has little scratches and dents. It's made out of something. And then we have sounds. I'm I'm not going to be touching sounds on my own presentation. Yesterday, Akalink was giving absolutely fantastic talk about sound design and how to create your own sound effects. So you should definitely be checking that out if you want to know more about sounds. As we're working on Unity, Unity has its own asset store. You can find a lot of free and paid assets in here. And this is probably going to be your closest source of material for your own world. But there is a little note. There are different categories of assets. You're probably not going to be seeing this too well. You have basically 3D models, you have textures, you have audio, you have editor tools, extensions, and then you have almost nearly every single asset. There is some kind of script, C# script, code that is supposed to make some object do something in the game. And this is where we're coming to a little bit of a disclaimer. Please note that VRChat doesn't allow custom scripts, C# scripts, to be put into your VRChat world. But we now have Udon Sharp, which pretty much allows us to convert some of these C# behaviors into Udon Sharp. So don't take my word for it. It's not guaranteed, but you should always be looking out for assets that are not dependent on C# scripts. This might be a little bit more advanced, but just I'm mentioning it so you can just look out for it and just try to understand a bit more. So 3D models. You have basically two different ways. You have the acquisition. You can download or purchase, or you can create them yourself. Oh, unfortunately, we're missing one line on the right side. But that was... I'm actually forgetting what was there. But basically, for downloading or purchasing your assets, you have some sources like Unity Asset Store, CG Trader, Booth, and Virtual Market. Especially Booth and Virtual Market are currently rapidly growing, and you can also see a lot of VRChat world creators adding their own models onto those services, so you can find something like a VRChat starter world, like a little kit that you can use to make your worlds. Or you can learn the modeling yourself. This requires some effort, unfortunately. You cannot just go into YouTube and look up any Blender modeling tutorial there is. So that's a bit of a disclaimer. You're going to have to take into consideration a few limitations of game engines, and you cannot really just make a really, really highly detailed, high poly model for VRChat and just duplicate it over and over and over again. There is something called, like, I think the general term game ready modeling or low poly modeling. Not really low poly for games, but generally like low poly in the range of 3D models in general. Then you have UV unwrapping. In order to have your textures fit your models, you're going to have to learn a bit of UV unwrapping if you want to be efficient and if you want to make your models right. And now I just remembered that the third topic is texturing. So these are the three main points that you have to learn if you want to create your own workflow for creating 3D models yourselves. Game ready modeling, UV unwrapping, and texturing. And then the next point about 3D models, pros and cons. For purchased and downloaded assets, obviously the pros is that you don't need to have that much knowledge about creating them. But the cons is you're going to have wide variety of creators, 3D modelers, talented, beginners. There are so many different price ranges. Like, there is not a set standard for price versus quality on 3D models. You're going to see a lot of variations. You cannot take the price for granted, or the quality for granted. And you should just keep in mind that sometimes you might need to open up Blender and actually fix your models for your project to optimize them and make them work for your project. The pros about creating the models yourself, obviously you have full control over everything. You know every single vertex that went into that model. You know every single seam, you know every single cavity, and you know what your model is made out of. And it's easy to fix as you have the workflow set up. And what did I write? Yes, can be sold. So this is also one potential source of income. You can sell your 3D models that you have created, and then you can create sustainability for your VRChat world creation. But the cons obviously is this is going to be taking some time, and it is a learning process. But if you're passionate, anything is possible. Then we're going to be covering those models with textures. My personal preference, obviously now it's a little intimidating, there is a price noted. Substance Painter is my personal recommendation if you're anywhere as passionate as me. It is industry standard tool for texturing your models. It allows for a really quick workflow, really easy revisioning, and just overall, just that guaranteed workflow that is going to be working throughout your world creation. So you have two different options. You have the subscription or the perpetual license. I highly recommend you go for the subscriptions because you get 360 different items from their substance source, and you also get access to all of their three different tools. You can create your own materials in any kind of workflow you would like. Or you can create those characteristics for your models right in Blender. You can paint within the 3D view onto textures. You will find some tutorials about that. I'm not going to be going into details on that topic. Or you can just fire up your favorite image editor, Photoshop, Paint.net, GIMP, whatever you like, and you can just paint some textures onto those UVs that you have laid out. Or you can find textures online. Obviously, this still requires you to have the UV unwrapped models. That allows you to slap all your textures on your models. But there are a lot of really good sources, and just search online for 3D model texture or textures. You'll find out. Please correct me if I'm wrong. I'm just trying to touch this as generally as possible so that everyone can understand. So game development versus VRChat world development. I really feel this is something that everyone should understand because it gives you a little bit of an insight on the differences that we're experiencing with creating the Unity scenes for already established platform that already has user accounts, support, all the moderation, their staff members working full-time on that platform that you can just push your content into. Versus establishing everything yourself, you have to do the networking, you have to pay for the servers, or if you're having peer-to-peer, that's another different thing. But you just have to create absolutely everything from scratch. You're making a standalone game. You have to advertise it, you have to have your own marketing for the game, and you have to find the audience. And in VRChat, we have the ability to revision really rapidly. We can just push upload on our world and it'll be visible for everyone else within minutes. So this is the ease of world creation, and if you're having a great idea, but you're just not really feeling confident in establishing the foundation for a standalone game, I highly recommend you come into VRChat and just start small. Like, start with world creation. It's pretty much like 90% there in the experience as it is in game development. You're still creating the environment, you're modeling everything, you're still doing the audio design. Obviously, the tools are a little different. You're having limitations in VRChat, but still, we have seen proof that it is possible to create award-winning experiences right here within VRChat. So don't be afraid to try it out in VRChat. This is one of the points where people are probably going to be hating me a little. I just want to be touching this topic a little and kind of explain the benefits of using Udon Sharp versus Udon Graph. So basically, if you were to do C# programming, I personally self-taught myself some C# programming in the past, and also some Python for making my own add-ons for Blender to speed up my work process. But basically, when I was looking for something with C# programming, I used to go anywhere like Stack Overflow or Unity forums, or listen to any kind of tutorials. And now you kind of have the same ability. You can just go into those forums, those chains, and you can just find information about programming that you can nearly one-to-one apply into Udon Sharp. But just first, get comfortable with how Udon Sharp works and how you're kind of laying down the foundation for your script, and everything should be really straightforward. And like I mentioned before, good portion of the already existing C# scripts should be convertible into Udon Sharp. So that is a really positive side. Actually, that last slide, I had my original drivable Udon vehicles both in Udon Graph form and Udon Sharp, and then side by side. It was exactly the same script, the first version of the vehicles, and that was kind of like the comparison between the two. But now we're getting into the similarities of the two. So when someone is complaining that they don't want to learn Udon Sharp, they don't want to learn programming, it's really hard. It's intimidating. It's understandable. It's a lot of characters, a lot of terms that you have to understand before you're getting into it. But I just kind of want to shine some light into the direct links between the terms in both of these methods of creating logic for your worlds. In green, you have highlighted the event that will be called whenever you're pressing a button. Whenever you're interacting with an object, you have that little blue highlight on the object, its outline, and that will be that will give you the ability to interact with the object. So in script, it's calling this event in this green outline. We have also declared the variables with exactly the same terms. It's stated as public. It's available variable to be called outside of the behavior itself. We have transform, which is basically the root component of every single game object. Game object is pretty much the wrapper of every single element in your hierarchy, and transform defines in which space in the world it's located at. So you can modify the transform, its rotation, position, scale, and those different things. So yeah, we're declaring the variables in the same way, and then we are getting the local player yourself. As you're executing this script for yourself, you are getting your local player, and then we are calling the method teleport to, which means we are moving your local player character into that transform in the world, and you have the same links between each one of the terms. So hopefully this will just give you a little bit of clarity on the connections between the two, and that was kind of just the one point that I wanted to get across. So what skills should you be focusing on? We had mentioned 3D modeling, programming / Udon. It's if you're doing C# or Udon, that's pretty much all the same thing. And you have texturing if you want to get a little bit better with texturing in Substance Painter or creating your own artistic stylized textures. You can. We have a lot of talented shader creators that are really popular and are being used on avatars and pretty much everywhere in the metaverse. So you have that. We're going to be having a talk a little bit after by Lyuma. That is something that you should really be checking out if you're interested in creating shaders. And editor scripting. I have personally been writing my own editor scripts for Unity ever since I pretty much started. It has been really useful just writing something out, just some one-time tool that does something for me, even if it takes the time to just write one editor window for doing one thing. It might be quicker than doing one thing over and over and over again, like we saw in Cyan Laser's talk. It's truly amazing what you can do with that skill set. So, final notes. Find inspiration. Find something that motivates you. Start small, get comfortable, get to know your tools that you're working with. Don't be afraid to fail. Ask everyone. Just let's bring Metaverse together into completely different level. We are here for the future, and we need talented world creators. Any questions?
Yeah, hi. I have a question.
Yes?
So, I know in other communities, they have sort of introductory hello world like frameworks, so kind of like you can download something and then you're kind of modifying something that already exists rather than starting something from scratch. I'm just wondering if there's any worlds that, if there's sort of introductory worlds that are available that you just download this Unity file. It has pretty much everything you need, maybe some of the tools that you recommended here, or if there's also other creators that are uploading like their entire Unity file up on GitHub or something like that that could be downloaded. So you could see an existing world that could also be modified. So I'm just wondering, yeah, if there's like an introductory world that's out there, or if there's also folks that are uploading and open sourcing their content.
Yeah, I will highly recommend checking out the VRC Prefabs database. I'm not entirely sure exactly what we have currently, but we have a lot of creators creating on a lot of different introductory prefabs that everyone can use. One of the fears with uploading.
When I say the prefab, I guess I'm talking about an entire Unity file, not a
Yeah.
prefab.
So this is what I'm coming into. One of the fears with uploading the entire project as a whole is you're getting a lot of copycats. But I'm pretty sure there are some starter worlds where you have some of the most common elements already in place. Honestly, I'm going to admit I'm not the best person to answer this question. There are a lot of VRChat, VRC Prefabs members that are going to be better well equipped to answer this question.
Okay, cool. Just if anyone has any more information, feel free to reach out. I'm just and also just share it here now if there's other information. So cool, thanks.
Yep. Anyone else?
I guess I'll just mention, sorry to jump in on the answer rather than the question, but the SDK itself does have an example scene that has a number of the basic like things you might want to put in your world, as well as a bunch of example scripts of how to use things. So I often recommend, as part of that, like, hey, just make sure you can build and test a world. The example scene is also meant to be that thing that you can build and test, and it should all work If it doesn't work, then there's something wrong with your install.
Yeah, if no one else has any more questions, I want to thank you, everyone, and hopefully you enjoyed this talk, and please enjoy the rest of the talk.
Yeah, thank you so much. So we'll have a 10-minute break now, so you can, grab some food, all that stuff, and after that we'll have a talk by table. And I don't want to spoil anything, but I just will say that every single slide is hand-drawn, so you have that to look forward to. So, yeah. We'll see you in 10 minutes.
Graph seems more fun than coding.
I'm in pain, I'm in pain, I'm in pain, I'm gonna die.
with the people who
about this one, so we'll see how it'll go. So yeah, please, table, come here and click take control and start the talk.
My stuff is floor so I can crouch.
Alright, I got a document for Twitter.
Right there. Right there. Out there? With everyone? Okay. Yeah, sure. Everyone's here? We all good? Everyone's present, right? Okay. Cool. We're all here. Nice. Hi, everybody. I feel like I should do some like preliminaries. I should talk about some stuff like initially on the offhand. First of all, I come from an improv background. Please do not feel like you have to stay muted. Like if you want to laugh, if you want to chort, if you want to like yell something, you want to tell me I'm a piece of shit, just go ahead. Don't care. So, thank you. Mwah. On the second hand, if I had more time, I'd probably be speaking in rhymes, but unfortunately this talk was done on a dime. So, improv. Thank God. Time. Let's go. Woo! Nice. So, alright. Why am I here? I don't know, there's a big bunch of text up there. Kind of outlines it. Let's get started. Non-standard optimization. Non-standard. What do I mean by non-standard? Everyone else tells you to merge your meshes. They atlas your materials. They tell you to crunch compress your textures and reduce those textures resolution, and I am here to tell you how to optimize your content in ways you may not have considered, using tricks you may not know. Ooh. Well, I mean, most of the people here are probably going to know at least a few of these. This is a shotgun talk. I am putting one big blast and assuming that maybe one of these will stick with you. If I can get one thing in your head, if I can get y'all to do one thing, I walk away happy. All right. So, who the hell am I? Why am I talking about all of this? Most of you here probably know at least a little bit, but for the people who are watching from home, and for some of those who don't know me that much, I go by Table. Name's Will. Nice to meet you. I am a composer. I do audio engineering work. I've been writing music for about 10 years, and obviously I enjoy drawing dumb stuff for fun. Most human beings know me as the guy who runs the largest art community on Discord. I'm also pretty well known amongst like Discord community, like community management channels as being like a consultation person. I do consultation for like telling you, hey, your community is this good or not good or whatever. That doesn't really matter. I don't really like doing it either. Thank you all for being so accompanying. I prefer to do this 50 million times more. I have been absolutely dummy obsessed with information theory and data compression like for years now. I can't really tell you why. I just really think the concept of like taking a certain amount of information and then expressing it exactly the same way but smaller, and then being able to take that same information on the other end and then I think that's the coolest shit ever. I think everyone should agree, considering most of the internet would not exist without data compression techniques that dated back in the 60s. So I mean, or no, not even 40s, radio. Everything media ever relies on data compression in a way, even all the way back to the early 1900s. Like, thank you. Thank you, very smart people, for doing a lot of very smart math. We're all very appreciative. As I am here, most people know me as a creator. I'm mostly focused on like, none of them are public yet, but I'm someone who focuses on like art worlds that are more for like the visual aesthetic and like telling sort of an emotion and narrative single player experiences. Multiplayer hard. Scary. I tend to hang around lots of public spaces and have met tons of creators doing that way. I have helped personally many creators with their world projects, actually making, their worlds like way smaller than they had to be. And as such, I am informally known amongst many as the optimization king. I don't think of myself that way. I think of myself as a lunatic. I am a lunatic. And I will get to that in a second. Most people here probably know me for creating the smallest, most optimized world in the game. I am proud of it. It was months of reverse engineering work. My artist rendition is very nice, very lovely, homeworld to many. I am very happy with how it came out. Half of the people seem to think it's cool. The other half of the people seem to think I'm a jack-off who just created VRChat's version of John Cage's 433. But you know what? I created VRChat's version of John Cage's 433, so what can you say? I'm a lunatic. I'm an absolute lunatic. You are listening to a lunatic. You are about to take advice from a lunatic. This is my mood 24/7. I need to make this clear. I will eat everything. It all goes in here. I don't care who you are. I don't care what you've done. I will eat literally all of your performance. It's all going in here. I am a lunatic. Raving lunatic, and you should take every single thing I say with at least a teensy grain of salt. Like, please do everything I say, but at the same time, keep that in mind. I'm sorry. After this talk, you should, it speaks for itself. This is where I want all of you to be after I am done with the, what says 25 minutes, hopefully more. Hit that hammer, hit the hammer, whack the cube. Don't whack the blue cube, whack the black and white cube. That's the one you need to be whacking. The blue cube is okay. We all love the blue cube here. Praise the fruit. Why did I grab the laser pointer? Okay, now you might be asking, Black Magic? Doesn't that sound like you're talking about Plank now? Are you just going to start going on about what exactly is stored in the... No, I'll do that later. I'm doing a write-up. You're fine. I've already addressed this. I'm having conversations with you before you ever have a conversation with me. Lunatic, let's go. Okay, so clearly I'm just, trying to avoid actually talking? Which is a problem when it's called talks. I think we should start talking. I'm gonna start talking. Fundamentals. Because it's always good to refresh yourself every once in a while, right? I think we can all agree. All right. Repeat after me, and I mean it. Repeat after me. Everything is data. Everyone say it.
Everything is data.
Cool. Now say the second one. Cool. Now say the third one. Okay, say the one below where there's actually text. Exactly. Everything is data. And I'm the amount of people the amount of people I have to talk to about this and they don't realize this is kind of astounding. I'm not gonna lie. Everything you put in is data. Every extra component on a game object is stored there. Every value in that is also stored. Every transform, every little bit of imprecision is kept there. If you have additional channels on something, it is kept. Everything is kept. Everything contributes. Literally everything. Even if you're sitting there thinking, that couldn't possibly contribute, it does. It contributes. Everything is data. So, fun times ahead in the Unity land. Cool. I'm going ahead of myself. I'm doing everything wrong. Woo! The more compressible the data, the better. The less data stored, also better. Generally, the idea here is that if you can make your data more compressible and not compromise your artistic integrity, you should. If you can put some level of detail towards something that makes more sense, you absolutely should. If you're making a cool vase, then do the cool things in ways that don't take up a whole bunch of data, ideally speaking. If you're going to make a vase with little flat colors, don't make them large textures you don't need for single color things. Don't use multiple solid color materials, which is usually more compressible, but performance goes down, and everything's a trade-off as you're about to see. You know, vertex colors are cool. Smaller little color atlases are cool. Keep doing cool things, you'll be cool. Don't do cool things, I will watch you in your sleep. Amazing. This next one is something I'm a little proud of. This is tables, tantalizing, triangle. You will not avoid this. You cannot avoid this. I already know some of you are sitting there thinking, well, I can think of an exception. No, there are no exceptions. High fidelity, high performance, low file size, pick two. Pick two. The caveat, the thing you should be thinking about, is the fact that I want you to imagine a little circle in the middle. It is easier to think of this concept when you're thinking of extremes. You're easier to think of like something like Planck, which would be high performance, low file size, but then absolutely no fidelity at all the way lined at the very bottom. You put 2 dots on each side, make a line in the middle. That's cool. Usually, you want your line to go through the middle of the triangle. Make a little circle in the middle. You want to pass through that somehow. Everything is a trade-off. And in effect, by going for one thing, you're going to be foregoing another, but you want to make sure everything's at least somewhat balanced. You can have something that's a bit of everything, but you lean more towards one thing or another. And it really just depends on the project you're going for. Usually, I would personally recommend, might seem a little contrary coming out of my mouth, but I would usually recommend foregoing the low file size in favor of making high fidelity and high performant worlds at the same time. Obviously, file size is important. But at the same time, performance is also important, because just because someone downloads your world once and then caches it, and they had to wait like 5 minutes to do it, doesn't mean that they're not going to have a good time enjoying their experience there. You know what's not going to make them have a good time enjoying their experience there? If they're sitting there with the mirror off, just looking at some nondescript, like, you know, location, like they're looking like this, and they're like, wow, 15 frames per second, reprojection. I'm enjoying all of this. This is great. My day is not at all ruined and my eyes do not hurt. We don't want that in VR. That's kind of important for your eyes to not hurt in virtual reality. Go for pleasedness. Unity compression. This is a quick one. Unity packages are just tarballs with extra steps. They use gzip. If you're trying to optimize your Unity packages for, you know, like doing the best sort of package content, read up on gzip, follow specs, make sure your data is like compressible to that format. What most of you should be caring about, the actual data bundles that, you know, every world is coming, is compressed with LZMA. Once again, read in the LZMA. 7-zip, pretty poggers. You know? Good format. Woo! Optimized design principles. This is a big one, and I'm not going to get into everything right now because it could be in its entire other talk. I could spend 6 hours talking about this. So obviously I'm going to go a little quick. Here's the important bits. Always think about where the player is going to be and what the player is going to see. Pretty simple, huh? Everyone's going to sit toward the mirror. Everyone's going to go where the most obviously, like, enjoyable objects are. If someone thinks, oh, this is a pretty view, they're going to sit by the pretty view. Like, optimizing your content around knowing where the people are going to be, what they're going to see, and what usually is being shown to them is everything, especially if you're making worlds that are not just like one hangout room. I am not talking for worlds who make one hangout room. This is very much a, you know, big world thing. Combination of message should always make sense. Don't combine every single mesh in your world into one. I had a big argument with someone about this. They were like, oh no, there's actually some, you know, black magic trick you can do to splice up sub-meshes and whatever. And I'm like, where have you ever seen that happen? And he listed a bunch of Unreal games. And I was like, that's Unreal Engine. This is Unity. Don't do that. Don't. Don't make everything one mesh. Unless, like, your entire world is a box. Which probably shouldn't be, but you know, I'm not here to tell you how to live your life. That's you. That's your decision. Obviously, if you're doing architecture and level design, cleverly hiding rooms and objects while inside other rooms, meaning like no windows, no partition gaps, no big wide entryways, or at least lessen them, means that you have an easier time actually working with occlusion. Four Ponies did that really good. I was thoroughly impressed with how your map performed in that regard. Good job! Woo! Yeah, so, like, I'm going over like small things, but just like throw me a message or something about this. I will talk about this for hours. I'm in VC all the time. Just ask. Much better than having to, pull up my time here for doing all that. Now you're probably sitting here and you're thinking, okay, so this is all stuff I probably could have figured out. When are you gonna just like actually give me the know-how? I'm thinking about it. I'm definitely it's on my plate. I could consider it. You know what? I think I'm gonna press next. Cool. Let's talk about LOD calling. You should be sticking LOD groups on as many objects as you feasibly can where you care about them not being rendered at a distance, or them not being rendered with Unity's rather esoteric occlusion culling system. I think all of us here know what I'm talking about. Unity's occlusion culling system. I thought I understood occlusion culling, and then I came to Unity and I was like, nothing makes sense anymore. Okay, so to get around this, designing around aggressive LOD culling can help a whole bunch when you're in a scene and you're looking at some distant building, and for some reason, just because you have a window open, half of the things inside the building are being rendered even though there's no way you can see all of them. And from what I have tested, someone can correct me if I'm wrong, from my initial tests, the overhead of having LOD groups on a good chunk of objects is just completely mitigated by the performance benefits you get from reducing that many draw calls. A good example of this is in my current map project blank. I have a cafe that is high up on a mountain, has like a whole like vista overhead, and pretty much everything in there has an LOD object, an LOD like with a LOD group on it. Why? Because when you're anywhere else in the map and you're just looking in the general direction of the cafe, everything gets rendered. Everything would always get rendered. It was like, okay, why the occlusion culling system just wants to say, all right, everything is visible, even though you are literally like a mile away and you're just looking at a little blip on your screen. The design of it being up on the mountain was an intentional design choice I made, because if you notice, there is literally no place you can be in the map where you can see everything inside of it unless you are either inside of it or right on top of it where the hole is, where you go in from the top ceiling, it caves into a hole and you fall down. You can only see everything in there when you are either in there or just above it, which means I could turn the LOD culling so aggressive that you could just be standing just below it, right where that picture on the very right is, and even if you're looking right at everything, nothing's being rendered because you can't possibly see any of it. Design around knowing where the player is going to be and what the player is going to see, and you can get much more aggressive optimization results as a result of that. Everyone who play tested it with me was like, oh yeah, that's way smoother. There's no more hitching when you're walking up toward the cafe. Lots of fun stuff. Next one's going to be interesting. This one made a whole lot of sense to me coming into Unity, coming from my audio background, but surprisingly, not a lot of people seem to understand this. So let's go over it together. I'm not going to sit here and explain lossy audio compression and or even just audio compression in general, because I could literally be here all day. Generally speaking, the lower the volume, the more compressible audio is. This is usually because two things. The amplitudes of the peaks being more similar to each other means the numbers are more compressible, so everything is more similar and it's not as extreme. And when you make everything quieter, especially if you're doing lossy encoding, the lossy encoders have more of a, hey, all of the stuff on the high frequencies are way quieter, so it's more of a bias. You can't hear it. Everything gets filtered out. That is purely those benchmarks are purely lossless. That is 3 of the same exact lossless file of a bad example, by the way. I intentionally did one that wouldn't give as good results as any other kind of file. A really loud DJ mix that I did back for a Halloween party earlier, a month back. And just by reducing the volume, you got first 6, well over 14 megabytes and then another 14 megabytes for half the volume, which is basically lossless. Not technically, but I'm not going to get into the whole just that. It's basically lossless. You could always crank it back up. And it just that much space difference. It makes a difference. It really does. Which leads me to doing this. If you are not working with dynamic audio at all and you are reducing the volume in Unity, you are doing it wrong. You're doing it wrong. Stop that. Re-encode the file, actually lower volume. Like if you're like, okay, you turn it down to Unity to 0.5 and you're like, this is a good volume for the music in my world. So I'm going to make it -6 dB. I'm going to export that out. Boom. Sounds exactly the same. And then you put it, obviously you set the volume to 1 in Unity. Sounds exactly the same. The file size is lower. You're welcome. Free space. Free space. Benchmarks here don't show that much of a difference because once again, I chose a really intentionally, like even if you have a really not very compressible thing, you still will get about 1 or 2 megs off of just making the volume a reasonable limit, which all of you should be doing because as you all should probably know by now, your audio should never be overbearing to the point where you cannot have a conversation even if your volume is at 100%. Please stop blasting out people's ears. All of you know this, but everyone watching, yeah, stop blasting people's ears. On that note, if you are doing any kind of audio effect in Unity and you are not doing something dynamic, please stop. Please stop. I will judge you. I will heavily judge you. I've actually seen this in the wild before. I included this slide because I have actually helped a few people with this. They're like, I wanted to do, like, for example, you want to have like a city world, you walk outside a nightclub, you hear a very low pass music coming from the nightclub, you're never supposed to be in there, so you're never going to actually hear the normal version. They're using Unity effects for it. It's using CPU at runtime, and the file is exactly the same. Go low pass it, like, bake the low pass in. File size of Resurrection from Celeste, trans rights, went from 14, just under 15 megs, to 3. 15, 3. Same exact thing if you just did it yourself in Unity. CPU usage is saved. File size is heavily reduced. It's not rocket science, people. You got this. I believe in you. You're going to notice a trend of just, hey, let's modify our data to be more compressible. I'm going to keep saying this over and over. Out of texture UV cleaning. This one is pretty straightforward. I know a couple people here already do this, but just in case you don't know, if you have a texture and you are not going to edit it anymore, it is like crystallized, you are just like, okay, I am never going to touch this again, open it up in your favorite image editor of choice, export your UV layout from your favorite 380 editor of choice, overlay the texture, or like overlay the layout onto the texture, add like a 5-pixel like border stroke, using like whatever effects you can in order to just ensure that the UVs don't like sample the colors from, you know, whatever when you're going to blacken it. Select all the dead space and blacken it. Like, don't leave all that extra data that literally is not being used there. Blacken it. Shave a whole bunch of space. If you're doing normal maps, obviously do that like kind of palish blue hue. That's like the baseline for normal maps. If you're doing something that's mostly one custom color, use the custom color. It's not hard. And then everything becomes more compressible. Your textures will love you. Your worlds will love you. This doesn't make any difference to memory at runtime, but, you know, Quest users will be like, oh, thank you so much. I really appreciate it. Bottom of my heart. Amazing. Let's talk about hierarchy optimization. So I'm not going to go too far into the I just thought it would fit. Don't look at me like that. I just thought it would fit. I don't know why. 3 days of crunch drawing all of these. Don't blame me. I'm not going to go too far into this because there are a lot more technical people on the internet who have much more to say. And you know, you can always go look at that. But just touching on this a little bit, since some people don't seem to understand this, every game object is additional overhead. So when you organize your project, everything is nice when you have like game object folders. But if you're running a massive project and you just have like hundreds, or like you're getting to the point where you're having thousands of game object subfolders and stuff, that is running. You are incurring overhead for numerous reasons. This is also the same deal if you're like making worlds entirely out of Unity cubes. Don't do that. We've seen this numerous times. Don't do that. The sheer amount of game objects are just going to initialize on load, and then everyone's not going to have a fun time. You've all been to the meetup. You've all seen this happen a couple times. And yes, the names of each game object are stored Don't name them stupidly long strings. Don't put the entirety of the B movie as the name of a game object. I'm gonna know. I'm gonna watch you. Oh, more relevant to the, most of what you all do. Keep pickups as close to root as possible. Like, every time a pickup or anything animated, by the way, this also applies to animated objects, obviously. Anytime anything has to update a transform, all of its children and parent objects have to update their transforms too. They also have to update physics systems and a couple other components. Like, everything in the background has to get updated for all the parents and children. Every time, every frame. Keep pickups as close to root as possible. If you keep all the pickups in your scene in one big folder at root, it is both tidy, and you're not going to just, have them strewn around in like a bunch of subfolders, because I used to do this all the time, and then just take up all that extra performance. All of those CPU cycles, we don't want that. Why do you want to use more CPU cycles? Everything is time, and time is money. Don't burn money. Optimize the stuff. Let's talk about mesh compression. Happy birthday, Hamsky. Mesh compression in Unity is a bit weird. There are a couple things. I'm going to get into some caveats, but generally here is some overall advice. You're going to see an option in your import settings called mesh compression, and almost always, unless you know exactly what you're doing, you're going to want to use this. Please, for the love of God, the precision of all of your mesh data will be lowered in order to be more compressible. You are literally just taking everything being 32-bit floats, and you are just making it not 32-bit floats with less precision. Chop it all off. Make everything zeros. Everything's more compressible. Low is indistinguishable. Like, if you're going to default to low. You're not going to notice a difference. Seriously, sit there for hours. You won't. It's indistinguishable. You have the file size of your meshes. Medium, you can kind of notice it a little bit if you strain your eyes really hard. It gets a little more, but there is somewhat of a visual difference. High, definitely a visual difference. You're going to notice it. But obviously, you're going to get a lot of space. I usually will only use high for things like distant LODs. Medium and low, I kind of alternate between whether it's important, like a big object where the precision of individual vertices is important, because I blew it up to 10 miles wide, and you're inside of it. Usually then you want to mesh, you'll be do low instead of medium, but most things should probably be medium. Talking a little bit about the actual format you should be using for meshes. UN16 is better than UN32. If you have a mesh that is 65,534 tries or lower, you can store it as a UN16. It'll be stored as halves instead of floats, which uses far less memory in some cases, and in most cases tends to be lower on file size. I'll get to that in a little bit. This is one caveat I just want to throw in real quick. I do not know this at all. Please, someone else correct me on this, or if anyone knows this information, I would love to hear it. I have heard through the grapevine that mesh compression, from before, and enabling read-write on meshes actually disables the ability for meshes to be UN16, and everything gets stored as floats anyway. I honestly don't know. I've tested it a few times. I haven't seen differences. I don't know if that's still true in Unity 2018. Would love to know if anyone out there does. Here's the deal. So I wanted to sit here and tell you how much better it would be to keep your meshes underneath that, and how much better with file size it would be. And then I ran a test, and this happened. And I don't know. I don't get it. I don't do this for a living. What am I looking at? Why is it 16 kilobytes bigger to shave off one try, even though it's supposedly being stored as halves instead of floats? Am I understanding computer science wrong, or is this something wrong with Unity? Is it something wrong with LZMA? Am I completely stupid? I don't know. It has baffled me for a couple days. I was like, okay, Unity? What the fuck? Hello? What? Okay, sure. And that's the real theme of this TLX talk. Unity throwing a curveball on a dime right before you are due to release or present something. You're sitting here all right, everything's going to be great. I'm going to just drop this bomb on you, and all you're going to be like, oh, yes, that's such a difference. And then Unity just does that, and you're like... Sorry, I died. I gotta load. Give me a minute.
How many megabytes you got downloaded there now?
I'm kidding. Unity, you're great. I love you. Thank you for enabling all of us. Thank you for enabling everyone to create the things they want to create. Get better. Please, for the love of God, get better. Please, for the love of God, let my, graphics card support, GPU light mapping in 2019. They fixed this in 2019 to 2020. They didn't backport it to 2018. Hey, VRChat, you want to mind hurrying up the new for 2019? Above all else, I love each and every one of you from the bottom of my heart. Seriously, I mean it. I have never, and I mean this from the bottom of my heart, I have never felt more at home inherently in such a short period of time in like a community, especially a community of like creators, as I have this. I love each and every one of you. I like really, I'm such a happy, I want to do everything I can. It's made me, like what Varneon was saying with motivation, it makes me want to do everything I can to contribute and like, because I come also from a background of like, I've edited Wikipedia a whole bunch, Discogs, I'm an archivist, I maintain a whole bunch of stuff. People know me for hosting public torrents and stuff. I like contributing to internet things. I want to help, and I've never wanted to help more than I have now. I want to just make so many cool worlds, so many cool prefabs. I want to try and do whatever I can to just help everyone get better at optimizing, help everyone get better at making the stuff they want to make. It really puts a lot of passion in me, and I could not have done any of that without the Cube Fruits. I love the Cube Fruits. Thank everyone for being there. And I would like to give double thanks to, as I put, Sugar Daddy Varneon, Crime Lord Skipper, FairlySadPanda, Banned for 100 Years Asus, No Showcraft, Numero Uno, Flower of God, Little Ghosty Constantine, and of course, my awfully hot coffee pot for putting up with all of my insane rambles and, general demeanor, stature, nomenclature, ones and flates, with my minds residing amongst all the time that I have left remaining, which is none. I'm sorry, no more fun. My name is Table, and that was my fable. I love all of you and everyone at home.
Try to clap at that avatar.
I don't even know what to say at this point. Are we even do we even want questions after this?
I will gladly take questions. I will gladly take questions if that is sort of
in the last 3 days, Table.
Okay, give me a sec.
More importantly, how much coffee have you had?
Well, it definitely wouldn't fit as a float. I can tell you that. How much coffee have I had? That much?
Double.
Probably that much.
Hot. Fuck you for
With
misspelling.
my small knowledge of Unity, your texture compression comparison visually seems wrong because you compare Crunch DXT5 versus Crunch DXT1.
That was me. I know that. I can promise you I actually did test the same format too. That was just because literally when I did it on the reference one, which was Panda's texture for the statue in my world, I happened to get rid of the alpha channels for the thing. It is more compressible, even if you keep the same format.
For your comparison, the legitimacy is reduced because of the DXT1 versus DXT5.
Yeah, I know. I know. I was crunching for 3 days straight. I know.
Nerd.
Trust me, I'm very aware of that. Yeah. Is that a...
Anybody else?
I've got a
I
question.
will answer anything. Yeah.
So this talk was a little bit over my head, but I think I got it. But I have a particular issue with compressing normal maps, and I'm not exactly sure what to do. I get all these weird artifacts whenever I try to compress it in Unity, and they go away when I disable compression, but then I have like a 20 megabyte normal map. What am I?
Yeah. I'm going to say, first of all, it's not actually 20 megabytes. Of course, everything does get compressed LZMA at build time. But, like, it still is bigger than it could be. The whole point of crunch compression is that everything gets modified so that when the final compression pass happens, it's more compressible data, and everything is a far easier time. Compressing normal maps, if you're not happy with the way crunch compression does it, then most of what you can do is sort of look at the texture, and I don't want to get on this too long because this is going to get into me actually like explaining like texture compression and like the way scan lines work and stuff, but like think about it like how much of your normal map do you really need? Can you get rid of a lot of dead space? Can you try and re-UV the object so that the normal map is much smaller but still conveys like a whole bunch more and keep everything one solid color, especially horizontally? Horizontal is more important than vertical. If you can make things compressible horizontally, everything is great. And then, yeah, like at that point, you just kind of have to modify the actual normal map itself, but just live with it, kind of.
Downscale it? Downscale?
Yeah, downscale it. You can downscale the resolution. I'm assuming it's not what he wanted, like level of detail, but
Yeah, but
yeah.
like, people don't really like. People usually keep it like 2K, and like honestly, a lot of things are tiled. So unless if you paint it in a substance painter and it's a tile, like if it's a tiled material, you usually can get away with scaling it way down to like what you think you might have usually do. So,
yeah, like I said, if you have like for example a normal map that's just like a bunch of like a texture, like maybe like a fabric or fur or something, like for like cloth, you could just re-UV it and then kind of scale it down, like you just crop it and kind of tile it, get the same results. You have to get a little creative with it. The idea though is that less data, less resolution, less higher frequency of between pixel changes, so the colors very drastically change. If you keep it kind of smooth, or if you keep it all the same color, everything's good, and you'll be fine. So more samey colors and lower resolution. If you don't like crunch compression, that is. Yeah. Bannerman?
Yeah, I do.
Ken.
Yeah, I'm wondering if. Oh, I'm sorry. Did you have one? No.
Go ahead, Ken.
Go ahead.
Yeah, I was wondering. In the web community, I know the basis texture compression is talked about a lot. Is that something that's come to Unity at all to be able to do basis texture compression?
I honestly I couldn't give you like that much of an answer. I'm not too in depth with like the Unity like if there's a basis compression like scene for Unity, I guess. I do come from like doing a lot of texture compression for web stuff and like little people's projects, programs and whatnot. I don't know honestly if Unity's got like a scene or thing for that.
Okay, yeah.
I'd love to know about it though.
I know that just in terms of doing Mozilla Hub stuff, a lot of folks have been sort of integrating the command line for basis texture compression, and it makes everything look great. So.
Script over everything.
So okay, cool. Thanks.
Yeah.
We have a couple of questions from the stream comments. First is from Legends, which is can have, and I already know the answer to this one, but maybe you can go into some more depth. Can having multiple LOD cause CPU issues if LODs are not needed?
If LODs are not needed, like I said, obviously every group is data, and every group requires a little bit of overhead for Unity to do the calculations of, okay, how far are you and how big is this thing on the screen? The point of the culling is you use them in cases where the sheer amount of draw calls that are being instanced on your machine are way too high for what you honestly need. For my case, where I, like, for example, you have the cafe, most of the time, the vast majority of the map, you're going to be looking at it. Like, if you think about it, like maybe 5% of the map is being there, and then 95% of it is not being there. So usually going to be looking more at it, and when you're looking at it and everything's being rendered and you can't see any of it, doesn't make any sense. So the overhead from all those LOD groups is like usually smaller than the actual performance that getting that culling in saves if you do it properly. There is a bit of overhead though. I think if you're like doing a devouring, I wouldn't say do this, like don't go slapping LOD groups on literally everything in the devouring. That's probably a very bad idea. Don't need to. You've already done plenty for that with like, you know, custom stuff. And if you can afford to just be like, hey, we're gonna just have custom scripts where if you're not in this area, just disable all the game objects once and then never think about it again. That's the ideal way to really do it. However, not everyone does Udon stuff, and usually this is something you do more for like small amounts of things than, you know, big ones. So don't put this on like literally everything in your scene, but if you have like problem objects, then this is a quick, cheap way of like, you know, trade-off optimization. You're making the trade-off of doing a little bit of CPU stuff, but then it's not as much CPU stuff because your computer doesn't have to go back and forth all the damn time. That's just
I'll add my piece of advice there. We did not use any logs in the devouring because it was an indoor, very complex environment in which inclusion calling did almost all of our work for us. We very rarely had something where you had a high detailed object you're looking for at from a distance. So, however, if you have a Breath of the Wild style open place, you have to do LODs, otherwise, you know, you can't function. So that's the answer to that question. Is it depends, because LODs also add memory. So if you are adding more meshes, you're adding more memory. So you have to balance depending on your particular application. Okay, next question from Ms. Stabby. Did you ever try to upload 2 identical versions of your map, but one before optimizations and one after, to compare memory/CPU between both?
Yeah. I've done this a couple of times, running like different tests where like I will have one version of the map. I go in there, I look at how it performs with like my real-time performance applications where I can look at it, and then I just do a render doc, you know, grab the whole thing, look at it a little bit, and be like, oh, okay, that was neat. I did that for Plank recently, because I very recently have been playing around with render doc. And then there were some times where I would do that in editor as well. I never would go so far as to upload multiple IDs, but usually just different versions of the same world. Like I would sort of like be like, okay, let me do all the changes for this. Cool. Revert those. Usually I would like have like some kind of quick way, like putting everything in a game object or whatever. Revert that. I'm like, okay, cool. Flip back a few times, be like, that was usually my process going through Plank, was just lots of rapid builds, being like, all right, I played around with these bits. When that changed, okay, cool. Poke around in the hex editor, see where exactly it is. Okay, so that's where that's located, which meant that if I change this value to be this, that's going to be more compressible because it's closer to the beginning of the file than the end of the one. So I'm going to keep iterating on that until you just crunch everything you possibly can. Yeah, lots of back and forth. A little crazy. A little crazy. I did say take everything with a grain of salt.
That's kind of crazy. I love it.
You know it. Anything else?
Okay. Yeah, I don't think so.
Going
So I think we're gonna. Yeah. I think we're good.
Oh.
Do mesh conversion matter on Avatar?
Yeah.
Yeah, I
Yes.
just try it right now, and yeah, highs it really destroy the model for sure, but the low pretty look the same as off. So I don't know what's the benefit on an Avatar compared to world.
Yeah, I did.
Oh, yeah, I actually had a question.
Yeah, load
which
time,
is,
basically.
do you know
Sure.
exactly what mesh compression is doing? So when we tried it on the devouring, and it was a big failure, mostly because our models were all extremely low poly to begin with, and so any amount of compression that was obvious tended to destroy them. And so I'm wondering if you knew, like, is it literally like decimation?
No, literally all it does is you have a vertice that's at some coordinate in space, right? It's stored as a 32-bit float. It's got a whole high amount of precision. All it does is when you do low, it's only 20 bits of precision. It just chops off like most of the end stuff. At medium, I don't remember the exact, I think it was 16, and then for geometric, it does it for like differently. Like I have the numbers on the slides, which you can all find later. Unity doesn't make it very obvious initially. You have to kind of take the docs for it, like in the scripting API. But all it does is it just reduces the precision of geometric, like position of vertices, the normals and tangents, and then the UVs. And that's it. Just lobs off the precision. So it's a lot. It's like it only applies to the mesh, and Unity obviously doesn't do anything. Nothing Unity does actually transfers over to the original thing. And it just stores that mesh in the build as a, hey, it's going to be 20 bits of precision per vertex for geometric stuff instead of 32. Which low, especially with normals and tangents and UVs, not usually needing to be as precise as they are, especially UVs. You can get away with lobbing off a whole lot of data that way. Like usually, from my testing, you do low mesh compression, half file size for that mesh compared to what it was in the build. Like it just halves it. So, yeah. Once again, if it's a small mesh, might use up more memory. Not sure about that, but it's usually beneficial. You might have enabled it like too high. Yes?
Don't use
I'd
it
love
on
to
a
hear
mesh
it.
collider.
Don't use it on a mesh collider. Somewhat, yeah. I see where you're coming from.
It's a reduction of
usually
reduction of visuals, so
yeah.
things that rely on colliders will break.
Yeah, no, especially if you're doing something where precision of like something hitting a corner. Yeah.
I'll let you use medium, but my units so near each other get destroyed.
I would say I noticed definitely like more benefit on a high poly mesh than a low poly one. Like especially if mesh has a lot of like, and also like as you said, like since it's precision, like it depends on like where exactly the vertices are and like how much benefit you're getting out of it. And so like the more like if you go high and your vertices like you can see like them shifting, right? Like especially if you blow it up at like giant scale, as you said. So it's like there is also like I noticed that there is a difference like how you scale things. Like if you import at the correct scale, or if you import it weird and then scale it up, like you can see different like cases where you have to be very careful of your like asset import pipeline, making sure everything is properly scaled, because then you start losing things where you didn't expect because it's like now interpolating all over the place.
Absolutely. It's like with most of the things I said, your results will vary. If you make a cube in Blender and you put all the vertices at exactly like 1 and then 1 and then like 1 and the other coordinate 1, whatever, and it's like 1.0000, mesh compression's not going to do shit. It's already compressible. It's already extremely like whatever. You're going to turn on mesh compression, nothing's going to happen. This is for when you have complicated meshes that a whole bunch of stuff is all everywhere and imprecise and 99.9% of the time. Obviously don't mesh compress like cubes. Yeah.
That would explain why it didn't work on our modular assets, which were all fairly precise.
Pretty much.
Okay, we really need to wrap this up. Like we already ran a bit over time on this one.
Ask me later.
Yeah, you can find Table on Discord, obviously. We're going to take a bit of a break just because the next one is an hour-long talk. So we had to push it a little bit here because Table had much more to share. So yeah, but next talk will be the last one. I just want to remind us, I forgot last time, but we're going to ask some questions from the chat. So if you're in the chat and you're curious about shaders after Lyuma's talk, just feel free to ask questions in the process or at the end so we can relay them in the instance. But yeah, we're going to take like a 5-minute break because we already had the long one, and we're going to dive right into the shader talk. Yeah, see you in 5 minutes.
That was great. That was
the last talk of the day. Can everybody hear me? Okay. So one thing before we start, one of the slides needed to be replaced. Lyuma has a slide literally on their avatar because they didn't want to bother anybody. So if you can show, like if you are hiding animations for people you do not know, you might want to click on Lyuma and show their avatar. It's guaranteed safe, just so you see the slide like on camera and stuff when they show it to camera. That's about it, and we're just gonna dive right into shaders, I guess. So
can
let's
everyone
take
hear
control
me?
and start it.
Or do I have to take control first?
Yeah, you have to click,
All right.
and then you click start, and then we're good.
Hello. So. Click start. Yes.
Yay. Okay. Good.
I can see myself. All right. Welcome everyone to shaders, and this talk is for everyone. There we go. This talk is for everyone. It's for people who have never written shaders before. I hope even people who have written shaders will learn something from this. So I do assume that you know some stuff about Unity. You know how to make materials and shaders and textures and meshes and that sort of stuff. And I am using Unity for this talk, but I do think a lot of the concepts here will be applicable to any system. I mean, if you want to make a shader on Blender or some other engine, I think you could definitely learn some things from this and apply it to that as well. One note though, if you do want to use a different program, there's actually two different dialects of shaders that are in common use. One, this talk uses HLSL, which is what Unity uses, also called ShaderLab. There is a different dialect called GLSL, which is from the cross-platform OpenGL, and you'll find OpenGL in wide use in browsers, for example. So if you ever browse ShaderToy or other websites, Neort or any website that lets you upload shaders, you'll notice that that code's written in GLSL, and that's basically there's not a whole lot of major differences between them, but there are a lot of little things. For example, HLSL lets you get away with just about anything you write. Like, it'll do something, but maybe not what you want. GLSL is a lot more strict, so if you want a floating point number, like a float, you actually have to say like 1.0. There has to be a decimal point in there, so it knows that it's a float. For example, there's also some naming convention differences. It says mix instead of lerp, vec3 instead of float3. They're pretty similar, but it's good to be aware of the differences because I do think ShaderToy is a really amazing reference, and you should be comfortable looking through some of those code samples and sort of extracting what you want from them and converting them between HLSL and GLSL, because most of the changes are pretty minor. There's a lot of documentation online for this stuff too. And also, some people are going to be wondering, like, well, what about visual shaders, shader graphs and stuff like that? I didn't want people to have to pay money to write shaders, and Amplify is an amazing tool for Unity, but it does cost money. And I don't think you have to... Amplify is a great tool, but I don't think you should have to use graph shaders if you're just learning. I think you can learn just by writing code. And for most of the simple things I expect people to be writing, I think you'll be fine with code. And also, Udon has kind of pushed people in the direction of learning a bit of coding anyway. It is a bit tricky to learn programming for the first time, I understand that, but it's a lot simpler than even the type of code you'll encounter working with C# or Udon. Most of it just comes down to the math. It's all doable, so yeah, if you're afraid of coding, I think you'll be just fine here. But if you have Amplify, you want to follow along the graph, it's pretty similar. There's just basically make a lerp node or a mix node instead of writing the function lerp parentheses. So yeah, so shading. Let's talk about shading. Shading can make really beautiful scenes. Some of the most amazing content you've seen in VRChat is done with standard shader. Standard shader can make probably some of the most impressive looking content, physically based rendering. And so while light baking is really important and proper lighting is really important, shaders are not going to help you with either of those things. So if you're looking to make the really amazing content, this is not the talk for that. So that said, Yeah, so this scene was made entirely with standard shader. There's no custom shaders going on here. So yeah, PBR exists for a reason. But yeah, so that said, when do you want to use a custom shader? So you'll find PBR tends to produce static scenes. I mean, it defines how something looks, but doesn't define any sort of animation. So if you ever want to animate something, or you know anything dynamic, you might want a shader for that. There's also some other common uses. I think pretty much every game or every map that has some water in it, the water is almost always using a custom shader. It's just one of those things that PBR doesn't really accurately describe how water behaves. So skyboxes, especially in Unity, skybox is kind of a weird, funky type of material. You would have to use a skybox shader for that. Toon styling, sort of a common example of that. Something that's not physically based rendering. It's your own custom shading model. You would want a shader for that. I don't know why I put particles here. Honestly, like additive blending standard particle shader can do just about most effects you'd want to do. But you know, sometimes you want custom particle effects. And also, if you listened to Cyan Laser's talk yesterday, which was really, really interesting, you'll notice that they used a lot of this fake light shader in Devouring, and those sort of deferred shading is actually really powerful and definitely worth using, and it's really not too hard to use. So yeah, for any deferred effects refers to effects where you use extra information rendered for every pixel on the screen. For in the case of the fake lighting, it's using the depth information, how far away each pixel is from the camera, and using that to sort of make it more dense or less dense fog depending on how far away it is. So yeah, that's an example of where you can use a custom shader to add something. Wireframes, other random effects also. So what does a shader actually look like? I don't know if you've ever double-clicked a shader file, but if you have, you've probably seen something kind of like this. If you have Visual Studio Code installed, which I highly recommend, or any other favorite coding tools, it's not Notepad. So if you've ever double-clicked a shader, you'll see something that looks kind of like this. So what's actually going on here? Well, so first, you've got your properties. So this properties block is really good to know about. It's pretty straightforward. Everything in here just goes in the inspector. That's what it does. You can also make like custom headers. You can make, make sliders and stuff. This defines what goes in the inspector, and you can add more stuff in the inspector as you want. It's pretty nice. So then there's uniforms. Usually these will match one-to-one with the properties. So basically you have you declare the inspector things, you can assign texture, assign a color, and then those textures and colors get actually put into the shader, so the shader could access that data. Now you have your V2F struct. I'll cover that a little bit more later, but basically this is the output of the vertex shader and the input of the fragment shader, and I'll cover what those mean in just a second. Also, just a little note, this example shader is quite short. Most shaders you open up will not be this nice and conveniently short to fit on a slide. This shader is unlit, which means it doesn't handle any lighting. It is just taking some pixels and telling the GPU to put that exact color on the screen without applying any lighting, and that's why it can be so short. An actual lit shader will have for base pass, add pass, shadow casting, and each pass is going to have to do a lighting model, and it's going to be a bit longer. So this concise example is only possible because it's unlit. But I'll cover a way to do more complicated shaders without too much code later on. So don't worry too much if you don't understand all of this. I'm just trying to make you a little bit comfortable with when you open a shader file, the stuff there makes sense. It's just, there's a few different parts of it. So let's look at what a vertex shader actually does. So this was actually extracted from the previous slide. It's exactly what's in the vertex shader. So what is going on here? So first of all, the job of a vertex shader is to calculate the x, y position and the z, which is like the depth for depth sorting of each vertex. You got your per vertex UV. If there's other stuff you need, normals, you can also put that there. So often, and that's the case in this slide, often you'll be able to just take data from the mesh, which is what's here labeled as V. The V, and for reference sake, the V in the function is actually passed as an argument called appDataFull, type appDataFull. So that's what comes from the mesh. That's exactly what comes from the mesh. The value in UV, therefore, is like whatever is set to in Blender. And so what this is doing here is it's taking that value from the mesh and putting it into the V2F struct, which is the output of the vertex shader for use later on. Because you're going to want to use the UV to do texturing. Click. Okay. Uses of a custom vertex shader. I'll cover some of these later on, but wind effects, extruding the mesh along the normals is a common trick to do outlines. So to do that, you could, any other sort of animation, and any complex calculations. Most meshes have way fewer vertices than pixels, so you can sometimes gain a lot by doing the complex math inside the vertex shader. So the math is already done when the GPU goes through each and every pixel in your mesh to actually draw them. So, what is a fragment shader? The fragment shader, also known as a pixel shader, it controls the color of each pixel, or fragment as it's called sometimes. So the fragment shader, in contrast to the vertex shader that ran on each vertex of a triangle, the fragment shader runs on each pixel of the triangle. And it is often the place you'll want to sample textures, which is what this code does here. That uses the text2D function to sample the texture using a texture, and which is called main text here, and the UV that, if you recall, we saved the UV from the vertex shader early on. So the UV and normals are calculated by the vertex shader, and they are provided but interpolated to the pixel being rendered. So your mesh contains only the vertices of the triangles. And so you might have UV of 0, 0, 0, 1, and 1, 0 on this triangle. But in your fragment shader, it'll actually give you a value of the UV that wasn't in your mesh. It might say like 0.3, 0.6. And that's because that particular pixel of the triangle got interpolated to that UV value. And so you can just pass that straight into the texture, and that's the exact right pixel of the texture to sample. So, and of course, vertex fragment shaders, you can paint any pixel within the triangle. You can't paint pixels outside the triangle. So if you want to do like a weird glitch sort of effect, you will need to do something a little bit more than just a custom fragment shader for that sort of thing. Let's see. So, yeah, there's other uses of fragment shaders. You can pretty much anything. Customize lighting, extra textures, noise, animations, ray marching, skyboxes. If you browse Shader Toy, every shader on there is just a fragment shader, because the vertex shader is paint inside the canvas. It's always a quad, so the vertex shader isn't even something to let you customize. Every shader in Shader Toy is a fragment shader, and you can see all sorts of crazy stuff there. So I will just kind of say anything's possible in a fragment shader. So when to use custom shaders? So I think one common case is optimization. So I'll cover this a little bit more later, but yeah, basically sometimes you can, with a very small amount of code, you can go and take something that would have needed like 10 different materials for something and make it into one material, maybe by using something called a UDIM. A UDIM is just basically when you have UVs, usually your UVs are 0 to 1, you can go and make a UV that's like 10 or 20, and it'll wrap the texture, so it still acts like 0 to 1, but then you can take that extra data, like how many 10s is it, and you can go and use that in the shader to do something. So for example, it could be like every multiple of 10, you change the color, and that what might allow you to use one material where you'd otherwise need like 20 materials, for example. And I think there's a trick that's been mentioned before about scale, using, you can take something that would need 20 different meshes and use the scale of the mesh to sort of pick out which one you want. So other things, animation, I've covered that before. It can allow for optimization, because instead of needing 1,000 animators or whatever complex animation setup you have, you just customize a shader, and the CPU doesn't actually have to do any work at all. So what are the other things? Immersion, we talked about custom fog effects, skybox, rain, snow, post-processing, that raindrop shader everyone likes. Can add immersion. Wind, I don't know if stencils are kind of a cool thing that can add immersion sometimes. You can make something, make an outdoor scene, or all sorts of immersive possibilities. Customization, I'll kind of go through this. Yeah, so basically allowing for extra texture maps can be quite useful sometimes, like detail maps or maybe different types of masks. You might want like a dirt and like a grass texture and kind of mask between them, or you might want like a decal if you ever want to like paint something on one particular wall but not the other. Actually, the TLX room Orals explained use a technique kind of like that. So let's see. Interactivity, so you can make overlays, subtitles, target indicators can be useful in game maps. You might want to like point to where a target is, and let's see, screen space effects, transitions, like all these things that, like, if you've ever been to like a really nice looking map, they kind of those extra little things that you'll often see maps do, that like fade out the screen nicely or transition something, or when you get hit with a sword, you get a little bit of like a distortion effect because, you know, you should feel that you got hit by something. So all of these add a little bit of something to the environment, and I would encourage the use of shaders in these sort of cases. So, draw calls. Stay hydrated. It's very important. All right. So, what is a draw call? So, what a draw call is, a draw call is basically a list of vertices and faces, triangles, getting sent to the GPU with a particular material and shader bound, and all the uniforms are set. These are all things that engine like Unity will have to do every single time you try to draw a mesh. Well, the vertices and triangles often be cached in the GPU, but you still have to like tell it which one to use. You have to bind the material. So there's a bit of work that's done for every draw call. So basically, one thing that you can that a shader can do, kind of like I mentioned earlier, is if you can get a single material and shader to do everything, you're going to be reducing the amount of time the CPU has to work. And in fact, you might allow for batching or instancing to work, which will again reduce the amount of work the CPU has to do. So that's kind of where shaders are relevant to the number of draw calls. But yeah, this is the CPU side. So what actually happens on the GPU when you do a draw call? So first of all, you're going to have the vertex shader run for every vertex in your mesh. And after the vertex shader runs, there's something called a perspective divide, which I'll cover later, but that's technically not part of the vertex shader. But first, we need to talk about spaces. So, and just as a reminder, a vertex shader's job is to transform vertex position vectors from object space to clip space. So what is a space? What does a space mean? Well, let's start with vectors. So what is a vector? Oops. So vectors are directions. So a direction would be basically the way something is facing. So in this case, a direction vector on this image is this arrow pointing up. So it's, let's say in this case, up would be represented as float 4 of 0, 1, 0, 0. So let me explain what that means. So a direction vector, let me start over, sorry. A vector is 4 values, so it's x, y, z, and w. In a more general space, you might see other sizes of vectors, but for the purpose of this talk, I'll just talk about 4D vectors and sometimes 3D vectors. So 4D vectors have x, y, z, and w. 3D vector would just be simply float 3 of x, y, z. So a direction vector I will refer to as a 4D vector of x, y, z, and 0. And sometimes float 3 just x, y, z. So this is sort of the notation. You'll see the words float 3 and float 4 in shader programs. That refers to a 3D or a 4D vector respectively. So a direction vector is often normalized. So you might often want, like, an up will be a direction. It doesn't really have a length, it's just up. So in this case, up would be 0, 1, 0, 0. So in something like Blender, which has Z up, it would be 0, 0, 1, 0. But, you know, there could be other directions. Let's see. So a position vector. So a position vector is x, y, z, and 1. So the W component for a position vector is usually 1. And so this vector is, let's say, like 3 meters above my left hand. So my left hand's 1 meter out, 1 meter up from the ground. And then 3 meters above that would be -1 for 0 and 1 because it's a position. So a vector is often stored as a float3 in structs, but you'll want to add the 1 back when you do math. And we'll get to that in just a second. So a direction is relative to a position. So that's kind of how these two types of vectors interact with each other. And let's see. So transform matrices. So basically a transform is a 4x4 matrix. And really, if that sounds intimidating, I wouldn't worry too much about exactly what a matrix means. You don't really need to usually work directly with the matrix. I'm just showing this here so you kind of have an idea of the type of data that you would find inside of a transform matrix. So a transform matrix contains the stuff that you'll set in your object transform in something like Unity. You will have your position, your rotation, your scale, and basically the translation or the position offset is in this last column of the matrix. The the rotation and scale are part of what's called a basis, and so that's the 3x3 matrix that's on the left. And the reason for this distinction, if you work with a direction vector, you actually don't want the position to be offset. If I go up, I'm like, well, what's up relative to you? You wouldn't go and be like, well, it's 0, 1, 0, 0, but actually plus some position offset. It would just still be up. So that's why the translation is in this last column, and it can be ignored when you deal with direction vectors. And the basis applies no matter what type of vector you're using. So yeah, so your 4x4 transform matrix is used for positions, and the 3x3 basis matrix is for the scale and rotation. And you'll another example of the distinction between position and directions. So a vertex position, like your vertex on the mesh, will be sort of a position vector, but your normals, your tangents, those sort of things are kind of more like direction vectors. So let's see. Yeah, and you can, of course, convert from a 3x3 to a 4x4 to a 3x3 matrix. HLSL will do that automatically for you, but that's what that 0 at the last coordinate does. So, what is a space? I talked about earlier this idea of object space and clip space. So what is object space? So object space is a space relative to an object's pivot. So this is like when you edit a mesh, whatever up in the mesh is. So for a humanoid, let's take a humanoid avatar, my head will be up in the Y direction, and if I'm lying down or sideways, my head is still up locally, potentially. Or maybe a better example is an airplane. An airplane's forward vector is like the nose of the airplane. The airplane can be facing any direction, but no matter which direction the airplane's facing, the nose is always at the same object space position. So there's world space. World space is relative to the world. So if a plane is backwards in the world, its nose is suddenly going to be at maybe -1 instead of +1 in the z-axis. So that's so that's the world space. And then there's camera space. That is relative to where the camera is. I couldn't really show it on this picture because you can't really tell where I took this photo from. I wouldn't be able to see its own position. So I just kind of put the cursor up there. But up is up, right is right, relative to where the camera is, not relative to where the object is. So finally, there's clip space, which is sort of a flat 2D projection. And clip space is a bit funny. It's represented as X, Y, Z, and W. The W is called a perspective divide. And the GPU will internally use that to divide X, Y, and Z to produce the perspective effect. So basically, the last sort of space that's interesting is called screen space. And screen space is what you get when you get X divided by W and Y divided by W from whatever you get in clip position. Anyway, this is all a bit technical, but just kind of remember there are different spaces, there are different reference points for your object to be in, essentially. And for some effects, it might be interesting to know, but most of the time, Unity does this for you. If you call the Unity object a clip pause function, you're getting you're getting a clip space position, and you can pretty much just end with that. So it's another thing. Clip space is sometimes called like post projection. Like the projection matrix is what takes something from camera or view space or camera space into clip space. And another thing to mention, like this clip position is sometimes just referred to as position, or in OpenGL it'll be GL position, or in HLSL it might be called SV position. Those all kind of refer to the same thing. So it kind of goes by a lot of different names, but it's all referring to this concept. So yeah, let's see. Yeah, and also one more note, this is in surface shaders, which we'll cover later. You don't even need to worry about this. This is all done for you. So what can we actually, what's the point of talking about spaces? Why is it interesting? Well, so depending on the type of effects you want to do in your shader, you might want to use object space. You might want to use for like, let's say something is like locally spinning or deforming vertices relative to the mesh. You wouldn't want that to deform in a different direction depending on which way your mesh is facing. So that would be an object space thing. But sometimes you want something world space. For example, like gravity. If you want something like float away from gravity, or you want wind or rain, you don't want your if you turn your object upside down, you don't want the rain going up. You still want it going down. So that's why you want to work in world space for that type of effect. Then there's camera space. It's actually not that useful usually to think of things in terms of camera space, but especially in VR, sometimes you want things relative to your camera and not relative to screen space, because screen space will be different in each eye. So that's something to keep in mind when you work with VR. But screen space you would often use for like post-processing types of effects, things that run for every pixel. So all right, let's go back to what we were talking about earlier when I said, here, let's first talk about spaces. Now, we've kind of talked a little bit about spaces. You know, your vertex shader runs, and it transforms a vertex from object space to clip space. The perspective divide transforms from clip space to screen space, and now you've got a bunch of triangles glued to the screen. That all of the depth has kind of been forgotten at this point, and now the GPU can go and figure out every pixel in those triangles on the screen. And those are called fragments. Each pixel is then tested for depth using that last z value, the z divided by w value earlier. That actually, you know, if something is behind something else, you don't want to show it. It's often referred to as clipping. If you have two objects of the same z, that would be called z fighting. That's what that depth and z value is used for. Other than that, it doesn't really matter. So yeah, you can test for something called stencil, and you can use the stencil and depth to make certain types of effects. So it is worth knowing about it. So then, now we're at the fragment shader. The fragment shader runs in every visible fragment and produces a color. And the color can be blended. If you want something transparent, that's done by calculating the color of the thing that you're rendering and then blending it with the thing behind it using the alpha value. So what is a use for a custom fragment shader? Or sorry, yeah. Fragment shader will sample textures. It will calculate lighting. And one thing to note about lighting, you don't have to do all of the lighting math yourself. Doing lighting math from scratch is quite involved, and I wouldn't recommend you start with that. If you're interested, Cat-like Coding has a great example, has a great tutorial series on building up a lighting function, but they do start with just using Unity's built-in lighting function, and you can call it just like you would any other function in your program. But you can also go and start with surface shaders, which we'll cover later. And with surface shaders, you don't even have to worry about lighting. It's all handled for you. You can still choose to implement your own lighting function, but you're not required to. So I'm not going to really cover exactly how lighting works. I don't think I can do a better job than what Cat-like Coding does. So I would highly recommend checking that out if you're interested in custom lighting. So yeah, then you might want to do reflections, refraction using the reflection probe. That's a cube map. The actual code for some of these things is actually pretty straightforward. The sampling cube map, you just give it a direction, and it gives you back the color of the reflection probe in that direction. So some of these things are pretty straightforward to do. You might want to do some other custom patterns. So then there's more advanced uses of fragment shaders. Tune ramps, light maps, ray tracing, ray marching, grab passes, water, fractals, whatever. I mean, the list is infinitely long, basically. But some of these things aren't too hard to do. I would you know, there can be cases where something like ray tracing might be useful. For example, a skybox which uses a like ground plane, so then you can make it look like there's actually a flat ground, even though it's a skybox. Let's see here. But first, let's talk about math. This is everyone's favorite subject in the room. I'm sure you're all going to be really excited about this. But math is really important for all aspects of game dev, and you should not be afraid of math. Math is awesome. Math is amazing. Anyway, so here are the things we're going to talk about. So we're going to talk about applying matrices to vectors, which is basic linear algebra, dot product, cross product, sine and cosine, which is trigonometry, and then some custom sort of shader concepts, lerp, smooth step. These are really useful, so it's good to learn about them. So yeah, if you haven't remembered your high school math class from 10 years ago, which all of this would have been covered in, don't worry. There's plenty of resources online, and that's why I'm covering this a little bit, just so you're familiar. But I need to quickly resolve the Steam VR issue. Oh dear. Let's see. All right, I'm cleared up. That was a bit freaky. All right. So linear algebra matrix operations. We touched earlier on vectors and transform matrices. So applying a matrix to a vector is basically transforming that vector from one space to another. That's the best way to think of it. That can be done with the mul function. The mul function, it does matter which order you do them. Matrix does matter which direction you apply the matrix to the vector. For our case, and for most of what you do with shaders, you're always going to put the matrix first and then the vector. So, so HLSL, you just call the mul function. And yeah, the example is, for example, you do mul, you pass in this unity object to world, which is a matrix that transforms from object space to world space. And you put in your in this case, a position vector, because it's 0, 0, 0, 1. I want to find the center point of my object in world space. So that float 4, 0, 0, 0, 1 defines an object space position. Run it through the matrix, you get back another position vector. But I might only be interested in the x, y, and z coordinates. Maybe I want to throw away the last one that's always there. So I can do something called a swizzle. So I just say .xyz, and that means just give me the x, y, and z coordinates, and don't worry about anything else. So you can also do other swizzles. You can do x, z, y to flip like Blender coordinates if you want to do something like that. Swizzles are useful. It's good to know about. You don't usually have to do too complicated swizzles, but they're there. It's a tool. All right. So vector operations. Normalize. Length gives you the length of a vector. Unit vectors are defined as vectors with length 1. Normalize, if you have something you're not sure if it's a unit vector, just call normalize on it. It'll make sure it's a unit vector. And that is often good practice. For example, if you take a normal and you set your like v.normal, o.normal equals v.normal in the vertex shader on each vertex, sometimes the interpolation process will cause it not to be a unit vector on each pixel of your triangle. If you're ever worried about it, just call normalize on it again. I know it's an extra operation. Don't worry about optimization right now. That's a whole other subject. Just call normalize. It'll make your life better. So it's a good function to know about. Dot product. Once you have things that are unit vectors, you can do some really cool stuff with dot product. So the dot function takes two vectors, and if they're both unit vectors, it returns how much they point in the same direction. So if two vectors point the same way, it's 1. If they point orthogonally, that's the right angle, it's 0. If they point opposite direction, it's -1. And if you've ever attempted to write custom lighting models or do anything lighting related, the dot product factors in heavily there. You can basically, you can make a pretty simple lighting function just by running dot and doing some stuff with that. You could pass the result of dot through a lighting ramp and make a custom tune shader. So it's pretty useful. And if x and y are not unit vectors, dot will also multiply the result by the length of each vector. So it can get a little bit confusing. One thing that's interesting, it's kind of interesting identity that we can cover, is that length of a vector is the same as the square root of the dot of a vector with itself. What does that mean? well, the vector in itself always point the same way because it's the same vector, so that's 1, and multiplies by the length, multiplies by the length again, therefore it's the square of the length, and so you can take the square root of that, and it's actually the same as the vector length. So that's kind of an illustration of how this concept works with the dot product. And sometimes you want to like, let's say I've got like 2 vectors that kind of point at an angle. Taking the dot of a unit vector with a non-unit vector will sort of like project the non-unit vector onto the unit vector and tell you how long it is how long its like shadow is on that whatever other object. So there's a lot of other stuff. Again, tons of resources online to read up on linear algebra concepts. Most of what you probably will end up doing isn't too complicated, so I wouldn't worry too much if this is a bit confusing, but it's here. It's good to know. Cross product. Cross product is well, let's start by defining again. Orthogonal unit vectors are those with a dot product of 0. So they're exactly 90 degrees apart on some axis, not facing the same direction and not facing the opposite direction. So the cross product of 2 unit vectors produces a third unit vector orthogonal to, let's do it like this, orthogonal to the 2 vectors you put in. So, and a cross product only works for float 3s, 3D vectors. So you can use .xyz to do it. And one of the common cases, and the reason I'm covering this, is that this can be used to calculate what's called a binormal from the normal and the tangent. And so if you ever take a mesh normal and a mesh tangent and you cross product the 2, you're going to get a binormal. And those 3 together can be used to make a matrix and a basis matrix, which you can then make a coordinate system relative to that pixel of the mesh. And that allows all sorts of interesting stuff that you can do. Once you have like a custom space, you can transform stuff into it. And yeah, so basically cross product is often used for sort of constructing this binormal vector from the normal and tangent. That's where you're likely to see it. So trigonometry, sine, cosine. So you can use those to make a rotation matrix. You can use dot of 2 unit vectors instead of running cosine. Sometimes you're given already 2 vectors, and instead of like converting them to an angle and back, you can just call dot, and that gives you the cosine. So you don't always have to use the trigonometry functions directly, but it's good to know that they exist. So yeah, the inverse of sine and cosine is a tan 2. So a tan 2, you give it the cosine, you give it the sine as the 2 arguments, and it actually gives back the angle that produced those 2 things. But this is not magic. A tan 2 has flaws. You have to be careful about it. And one of the big issues with it is it will have a discontinuity at 180 degrees. So it's good. Sometimes you'll write code that uses like sine, cosine, a tan 2, and you're like, well, wait a second, I could have just taken the x and y coordinate of this unit vector and just use that instead of the sine and cosine. And it works out often that you don't even need the angles in your math. It'll just take the x and y and do this or that with it. So it's good to know about. It's also good to consider that there are flaws to using angles because of the discontinuities. There's also a cosine, arc cosine, however you want to call it. And that can be used for, like, for example, like the vertical angle. If you want like a 3D sphere, there's 2 angles. There's like the latitude and longitude. So one is with a cos and one is with a tan 2. So, but yeah, again, you have to consider when you want to use angles and whatnot, and be aware of the fact that the discontinuities might cause like the texture maps to be sampled incorrectly and stuff like that. But there are a lot of uses for it as well. And if you want to make a matrix using the sine and cosine, there's actually a function that I always copy that's like, it takes an angle and an axis and produces a transform matrix. And you can essentially, again, use this to define a custom space and then transform stuff into your like custom reference point. So, lerping, interpolating. Oh, actually, sorry, I stuck on a random thing here. Multiplication is useful, can be done on floats, but also can be done on vectors. And when you do it with a vector, it just multiplies every component in the vector. So you can multiply, for example, a vector with 2, and it'll essentially make the vector twice as long. It'll scale it. You can also add 2 vectors together. All of these things can be done. Multiplying 2 vectors is kind of weird. It just multiplies each number of each axis. So it's not clear that it's not commonly used, but that's what it does if you put star. So what does mean to lerp? So lerping interpolates from point A to or from some value A to some value B. You often see this maybe with colors. So you might want something like, I want something green, I want something orange, and then I want to make a nice and smooth transition between the two. You put lerp of green, which would be float for 0, 1, 0, 0, 0, 1, 0, 1, and orange would be like whatever. And you would pass those two into lerp with a interpolant, and it'll go from 0 to 1. One thing to note, this third value in lerp is like, if it's 0, it returns A. If it's 1, it's B. If it's in between, it's in between. If it's below 0 or above 1, it'll actually do kind of usually undesired stuff. So the next functions, anyway, question mark colon. I'm just putting this here because a lot of people aren't familiar with it, and it shows up a lot in shaders. I don't necessarily suggest that you use it, but it's there, and it's good to know it exists. And what it does is it chooses, depending on the first condition, it might be the thing after the question mark, or it might be the thing after the colon. It'll be one of those two results. So it's kind of used in place of a lerp, where you don't actually want the in-between, but you just want to have either exactly the first value or exactly the second value. Step. So the step function is 0 until x hits A, and then it's 1. So it's good to view this function as like a subscript. If you ever worked with the math functions, it's like step subscript of A of x. So it like A is the stopping point, and then x is 0, 0, 0, 0, and then 1, 1, 1, 1, 1, 1, 1. So that's what step is. This function smooth step is really useful and quite commonly used. It's good to first talk about step, because smooth step is basically, it's step, but instead of a single value where it jumps from 0 to 1, it's kind of like 2 stopping points. If you ever use like a gradient editor, for example, it's kind of like, it would be like if you put like 2 stopping points in your gradient editor and like had 0, 0, and then like dot and dot, and then like, and then 1 the rest of the way. So yeah, smooth step basically, and smooth step can often be used as the third argument to lerp, and it nicely avoids the whole issue of, well, what if x is less than 0 or greater than 1, because it makes sure that the resulting thing is always between 0 and 1. So smooth step is a really nice function. It solves a lot of issues. You can pretty much put anything there and put some like stopping points for A and B and put in whatever x you want, and you're always going to get something nicely between 0 and 1. Yeah, and shaders come with tons of functions by default. Like, literally has a built-in function called reflect and refract, and if you give it the vector and your normal vector, it'll just tell you where it reflected or refracted to, and you can just pass that straight into the cube map. So you, like with 2 lines of code, you can pretty much write your own like, reflection or refraction type function using a cube map. So it's pretty simple. I'm going to put a link later on in the slide, but there's HLSL Microsoft documentation has like a list of all the functions there, and so highly recommend reading through that if you're ever interested. Surface shaders. So now we're going to write our own. I'm going to show you a little bit how to make your own shader from scratch with no knowledge. So if you recalled, I showed an example shader earlier, and there's a bunch of lines that you probably didn't remember any of that. I don't expect you to remember any of that. That shader was unlit, so not only was it like, there was a lot of code you'd have to customize, it was completely unlit, there was no lighting. If you brought one of those things into this room, it's going to be like bright as the sun. So, and writing sliding code from scratch is challenging, and you can follow the cat-like coding examples and call the Unity's lighting function, but that's still a little bit involved. There's, you don't want to have to do that work every time you write a shader. So, and I said shaders are supposed to be easy, so we were fortunate. There's a thing in Unity called surface shaders, and surface shaders take care of all of the annoying stuff for you. So I highly recommend starting to learn using surface shaders. And it also happens to be what Amplify uses for a reason, because it does all the annoying stuff for you, and it's nice and simple. So, if you even use Amplify, you're actually using surface shaders underneath. So let's go and make a custom surface shader. So basically, if you ever go and right-click on your asset in your project assets, you can go to Create, go to Shader, Standard Surface Shader, type in a nice file name and hit enter, and make sure you have Visual Studio Code or another equivalently good editor. And if you double click that, you'll get exactly what I put here in Unity 2018. I removed the comments and white space to make it fit on the slide, but essentially this is what you'll see. This is a so let me quickly explain the different parts. There's the blue boxes, the gray blue boxes are the properties and uniforms. Just like we saw earlier, this is the inputs to the shader. These are the things you would set in the inspector, and they'll show up in there, and you can just use them. Like your texture, your glossiness slider, your color, these all get fed in as inputs there. It also has this nice thing called Unity Instancing Buffer Start. It's just handling that for you. Anything you put in there can be done with GPU instancing. So you're free to use that to optimize stuff later on. And there's the thing I referred to previously is V2F. That is the result of the vertex shader and the input to the fragment shader. That is here called struct input. And so the stuff inside struct input are sort of computed by the vertex shader. And even better, Unity will calculate this stuff for you. You don't even have to write the vertex shader. You have to use the correct names. So if you go to the Unity surface shader documentation, there's a list of like official names of things you can put in the input struct. And just by writing a variable with that name, it'll use that. So I brought here a little example program that I was. So this is a modification to this. I added a few extra float variables, and anyway, I don't. Yeah, basically, oops, here it is. Brought in a little toy. So this is what happens when I add these lines of code to the new Unity surface shader. So I made a little Fresnel. I just copied a code sample online for this. It's a few floating point values to define how the Fresnel works. And the vertex motion I'll get to in the next slide, but that's also on here. And then if you see, there's a bit of a scrolling effect with blue scrolling, and that's handled by these last two lines on the slide. So I get the sign of time and the world position, the y world position, and I store that in a variable. I multiply it with itself to make sure it's always between 0 and 1, because sign gives you a variable between -1 and 1. I don't know if this is readable on the video, but I'll try to, yeah, anyway. Yeah, so basically, I was able to make sort of a scrolling, like vertically scrolling effect by making sure it's positive and then using the POW function. The POW function always needs a positive number. It'll sometimes malfunction if it's negative, so always make sure it's positive. And then a power, so I made to the 10th power, and that produces kind of a cool like scrolling effect over time. Sometimes a little blue thing will kind of slide down. So that's that. So that's an example of something you can customize with the surface shader. The Fresnel, I calculated something in the vertex shader. So I added something that says like o.Fresnel equals and some formula I copied from the internet. Let's go, I'll cover a bit more detail the vertex shader part of this. So because this is sometimes a little hard to find the exact documentation for this. So the vertex shader for the vertex motion, the thing that made that sphere move up and down. So this is a, so these are the only changes I made from the right-click new surface shader. So I added 2 new properties. So it's a direction that the sphere moves. Like I want to move it up, and then a period, which is how many seconds between pulses of the sphere. So I added in the properties that made it work in the inspector, so I could just go in the inspector and set it. And then I had to also add the float for the direction because it's a vector, and the float for the period because it's a float. It's a single number. And I added those to the uniforms part of the code. Then I added a vertex shader to the hash pragma surface line. And this is sort of this is just something you copy and paste. You don't have to. I wouldn't suggest remembering this because the syntax is a bit confusing with this stuff. But basically, just know you can add this little thing. You can add a bit of extra stuff into the pragma surface, namely vertex:vert, and add shadow is important. That's like, again, surface shaders do a lot of stuff for you, but you have to tell it to do the stuff for you. And so the add shadow means if you don't put the add shadow line, it'll assume your object doesn't move and use like a default shadow. And so your shadow is not going to move, but your sphere moves, and it'll look kind of weird. So writing add shadow fixes that, and it makes the shadow work correctly. So good to do that if you do anything custom in the vertex shader. And finally, the actual code in the vertex shader. So let's look at what that does in more detail. I'm going to zoom in on that. So the vertex shader, again, first 2 lines, it's a function declaration, some input, in, out, out. This is straight from the Unity documentation. I don't suggest you remember this. Just know that there's 2 lines of code you have to write here to start the vertex shader. So we declare a new variable. I'm calling it rolled up because I wrote this before I made it a parameter. Now, a custom thing in the inspector, it doesn't have to be up anymore. But I left the variable with the old name. So this is taking that direction vector we specified as an uniform input and multiplying it with the world to object matrix, because I wanted my direction to go up and down regardless of which way I hold the sphere. So it always goes up and down even if I put the sphere upside down. So I just decided that would be cool. That's why I did it that way. And that gives you a direction vector in world space. Now we want to calculate the actual motion. And so I like to use sine. I think sine is a really cool function because it's always periodic. You can pass the time into it and it'll change over time, but always be within some nice range of values. And because of how sine works, it wants an angle and I want time. Aren't really the same thing, so I just multiply by 2 pi. And I divide by the period because if you multiply it by frequency, and so if you want something time-based, you divide by the time. Kind of frequency is 1 over time. So it's that sort of quality. So finally, I take this x value, which is this periodic -1 to 1 value, multiply it by the direction, and that'll now produce a direction that's scaled by this number between -1 and 1. Sometimes 0, sometimes the direction, sometimes negative the direction, and in between. And I simply add that to the x, y, and z of the vertex. Now note that I could have just left it as plus equals without doing dot x, y, z, because the w for a direction vector would be 0. But just to be safe, I did dot x, y, z. That means I won't mess with the w value. So, yep. And that's basically what a vertex shader would look like. So, in conclusion, I'll cover a few other things that shaders can be used for that I think are really good to know about. But first, let me hydrate myself. All right, so what is a GPU actually? What is in your RTX 3090? Well, it's basically a processor, much like your CPU, much like your Intel processor or whatever else. Its job is to take instructions and execute them and calculate whatever result you desire. But unlike a CPU, the GPU is designed to work with bulk data. So instead of a CPU which runs 1 line of code at a time, the GPU is designed to take 1,000 pixels at one, or probably 32 by 32 or whatever block size, and process them all at the same time. So it's designed to do a lot of stuff of the same type at the same time. So, for example, you might want to take all your vertices at once and then run the vertex shader on all of them, or take all the pixels at once and run the fragment shader on all of them. So, if you think of using if statements, that can actually slow things down significantly, because if you take multiple branches, it'll have to process both branches and do a bit of work there. So it's good when you think about writing stuff for the GPU to think of it processing data in bulk. So, and in terms of computation, it's good to think about the inputs and outputs of what you write as a shader. So, in the case of your traditional vertex fragment shader, your inputs to the vertex shader is your data straight from the mesh. The output is this v2f struct, that's sort of this temporary data that goes into the fragment shader. And then your fragment shader's output is the colors and the depth value as well. So yeah, so the inputs, well, in addition to the mesh data, you also have uniforms. There's a lot of different types of uniforms. Uniforms just mean anything that's the same for every vertex of your mesh, or every pixel of your mesh. And also, of course, textures. Textures can have lots of data in them. Those are also inputs. So, and then other types of uniforms. There's actually a lot of different places uniforms can come from. There's material properties, instance properties, material property blocks in Unity, which is like a per mesh thing, like set by animations, for example. Uniform arrays, which you can set using Udon. And then, of course, there's a lot of built-in variables, like where's the light, where's the camera, and time. The time value is a built-in one. So now we have the outputs. The outputs of a shader would be, your colors, your depth. If it writes a stencil, it might write the stencil as well. Those are all things that like shaders can eventually update. It's much fewer things than you would see as inputs. There's a big, I'm not going to go into it, but if you use compute shaders actually allow you to write the same types of things that you can input. So they're very powerful, but I'm not going to cover that. So, and if you want to actually use shaders to compute stuff, you can actually use cameras, custom render textures, and like I mentioned, compute shaders. So those are all ways that you can capture the result of a shader instead of just displaying something on the screen. So and then, yeah, of course, you can then take that data back to the CPU using like get pixels and Udon or any other sort of async readback. So cameras and render textures, they're cool. You do simulations, game of life. I mean, we have some people in the audience who make neural networks. That's another valid way to use them. Encoding, decoding data. So if you've ever seen the system called Shader Motion by LOX9973, it actually takes pixels from a video and reads those in the vertex shader to do mesh deformation using the same techniques you would use to make a skinned mesh work. So there's lots of different uses for processing data. And I'm not expecting you to sort of learn this from scratch, but it's good to know that it exists. Good to, sometimes think about like when it might be an appropriate solution for the type of problem you're doing. The GPU is very powerful, and you can do really cool stuff if you make use of the power the GPU provides. So, and drawing onto text. Okay, with that said, I have a ton of really useful links. I'm just going to quickly test this out because it's malfunctioning. Okay, it does work. Okay, so with that said, there are some really useful URLs to reference. Bookofshaders.com, it's a great website. Cat-like coding, it's really good tutorial, especially if you want to learn how Unity lighting works. Shader Toy, pretty much everything under the sun, but it's all done in the fragment shader. So they actually write their own ray tracing or ray marching, but there's tons of interesting stuff in Shader Toy, and I highly recommend, again, like if just looking for stuff and copying the code and playing with it. And of course, you have to convert from GLSL to HLSL. That's a pretty straightforward process for that. There's another thing. If you work with Unity, but even if not, Unity has all the source code to their shaders online, available to download in MIT license. You're free to copy whatever you want from it, but they don't give it as part of the Unity editor for who knows what reason. Instead, they give you this weird 100 kilobyte zip file you have to download from a special place. I recommend downloading the zip file if you do any work with shaders. If you extract it, there's two folders. There's default resources extra. That's where the source code to all the built-in shaders, like standard. You can actually look at some of the code there. And CG includes, which is all the things you do pound includes, which I didn't cover in this talk, but pound include, hash include gives you access to built-in functions, so it's useful. Or you can separate your code into multiple files. So CG includes is all of those files. It's all there. So highly recommend using Unity shader source code as a reference. And it's not on, the stuff online that's outdated or just not there. You have to just download it yourself, unfortunately. I don't know why Unity doesn't publish it. And then, of course, the Microsoft HLSL documentation. It's a great place to find information. Most of the stuff, you'll just Google it and it'll show up. So you don't need to copy these links necessarily, but there they are. So yeah, I appreciate everyone listening to this talk. I hope, even if you haven't learned everything, because I don't expect anyone to be able to learn all of this stuff. I haven't even. But if you learned even anything at all, I hope this is helpful. I hope it makes people less afraid of writing shaders. I don't think shaders are something to be afraid of. I think they should be treated as a tool, as something you can use to make your content better. It's definitely not required for all types of content, but it is a tool. And don't be afraid to ask for help. Again, don't be afraid to Google for help. Don't get frustrated. It took me a year to get even basic familiarity. So, yeah. Any questions?
Do you want to ask questions, or can I go?
I think you're supposed to step into a special box.
Yeah, it's over here. There is a spot over here. I'm not by any means a shader programmer, but I do some things from time to time, and I'm not smart, so I could have probably Googled it. But since you are here, I wanna ask a question. What the hell does a uniform mean, and when should I put it in front of a thing? Because I usually don't do that.
I had that in my notes, and I forgot to mention it. Good question. And let me see if I already wrote the answer to that question. No, anyway, I'll just explain it. So, there's actually one of those dialect differences between GLSL and HLSL. It's actually really good to be aware of. So, in HLSL, anything declared in global scope that is outside a function is uniform by default, and that's really important to know, especially if you go and say, I want to write a constant. So if you just go and naively say like const float pi equals 3.1415 semicolon, that variable is going to be 0 when you run the shader. Do not do that. Always say static if you don't want it to be uniform. Because by default, it's uniform, which means it'll expect you to set in the inspector, and if you didn't, it's going to be 0. So yeah, that's why you often don't see uniform before variables in HLSL, because the default's to uniform. So it's good to be aware of that. In GLSL, it defaults to essentially what HLSL calls static. So if you write a global variable, and you'll see some shader toys do this, you just say like float foo equals 5 semicolon, that declares a sort of just a temporary scratch space to set some value or make a constant. So in GLSL, default is static, and you have to I don't even know if you can say static in GLSL. You just don't say anything, and you have to say uniform in GLSL to make it a uniform. But the term uniform refers to both types of refers to those variables, even if you don't write the word uniform in front of it. It's still the same for every pixel of your shader, hence it's a uniform.
Okay, yeah, okay, that makes sense. It makes sense that it's implied because it didn't break anything, right? But I never wrote it explicitly in this case.
Yeah, you don't have to in HLSL. It just does it for you.
Are you muted?
Are you on the correct
I can't hear you.
Sorry, I'm back.
Oh, cool. I hear you now.
So there's a pretty mind-blowing demo that Inigo Quiles, one of the co-founders of ShaderToy, did just within the last couple of weeks, where he was able to essentially create an entire scene using SDF.
Oh yeah.
And
IQ is amazing.
But I assume that, like you said earlier, that's sort of painted onto like a 2D canvas and gives the illusion of like a 3D scene. But have you seen? Are there any VRChat worlds that just are kind of from the demo scene, just entirely shaders and?
Yes.
And
there is. Have you seen Treehouse in the Shade? Treehouse in the Shade is an amazing demo of what you can do with shaders, and some of those are actually straight from ShaderToy. So there's something I didn't cover in the presentation, but the fragment shader can actually write to the depth value and can produce things that have depth in 3D space as well. And a lot of times, if you transform something from ShaderToy, which I didn't cover, but one of the techniques that you can do when you're translating stuff from ShaderToy, look for the ShaderToy using variables RO and RD. Those are usually the ray origin, which is the camera position, and the ray direction, that is the direction from the camera to that pixel of the material or the object. And there's often some camera code before that. If you want to port it to work in VR, just delete all the code before the RO and RD, or all the camera-related code, and replace RO with _ in Unity _ world space camera pause, and replace RD with normalize of world pause minus, or mesh.world pause minus world space camera pause. Yeah, basically, if you replace those two things, you'll essentially get something that works in VR in stereo, because each eye will have its own position and the math just works. So
awesome.
Yeah, and the depth thing, if you want to calculate depth, there's a process where you can set something called SV depth, and if you assign SV depth to the correct value, that has to be like, there's a function that like converts to like linear depth from 0 to 1, and if you assign the correct depth value to that SV depth variable, it'll actually clip with geometry. You'll actually like put your hand into it to like clip into the stuff correctly. So there's a process for that. I can't tell you offhand exactly how to write that code, but it's not too bad, and once you do it, it works.
Yeah, just a quick follow-up to that, because since it is possible, then is there like a bare minimum of like geometry that you need to just have the avatars moving around? Because I can imagine like with creative coding, you're able to do all sorts of stuff that it could be sort of abstracted out to the point where, you know, it would be difficult to actually have multiplayer avatars in there. So is there like a bare minimum that you need in order to sort of build on top of that?
It's a bit of a complex question. I encourage you to reach out on Discord or anything if you want to chat more about this. But basically, I mean, if you're just starting with something, I would suggest just taking a cube. Just make a cube and put your code on there, and every pixel of the cube will just run the code you write, and it'll look like whatever scene you put in. So if you're talking about making like something like an interactive like avatar that's Raymarched or something, that gets more involved for a few different reasons. You have to actually learn the bone positions, and that would be a bit more complicated, but you know, anything is possible if you put your mind to it.
Cool, thanks.
Definitely check out the treehouse though if you haven't already.
Yeah, Treehouse in the Shade. If anyone hasn't been to that world in VRChat, it is amazing. It is probably, especially if you're in VR. I would suggest everyone who has a VR headset, if you've never played VRChat, get VRChat, go to Treehouse in the Shade, and see that world. It is incredible.
Yep. Any more questions? No? Okay, thanks. I don't think Troller is sending up for a question, so.
Woo! All right.
I think thanks for the talk.
Thank you. It's been a pleasure to give a talk.
Hey.
And please contact me on anything, Discord, Twitter. I love being contacted. Ping me, whatever you want. I enjoy it.
Okay, I'm gonna click a button real quick to say some final words, and we'll be off. Okay, I hope you can see that, and it's synced. Tell me if you do. It should say end of day 1, end of day 2. Okay. Well,
365.
yeah, we're not there yet. Not on the 2021 yet, sadly. But yeah, this is the end of day 2. This is the end of TLX. I just wanted to say the first installment of TLX. I just wanted to say huge thank you for everyone for coming here. Huge thank you for taking some pictures, sharing them on Twitter. I saw like this stuff really just brought me joy when I was falling asleep, completely starved and just like devoid of any energy left in the body. It was an amazing experience to build all of this and just, you know, I don't know, bring some of that conference enjoyment that I kind of lost with like all of the current situation in the world. And yeah, I'm just hoping that it will not be too long until the next event, and we'll get even more and I don't know, cooler talks, and more people maybe even get to the point where we can run multiple instances at a time. I'll try to fix today. Thankfully, ran pretty smoothly. I think we didn't have to jump instances. The stream seemed to be up. So, but the world is still work in progress. So I'm excited to make this more of a learning hub with documentaries, GDC talks, all of that kind of stuff organized, as well as here, as well as on the website. But yeah, it was cool to see on the stream there were 50+ people watching, and those tweets about the talk were one of my most popular ever. So it's really cool to see people excited about the same things that I am, and I'm hoping just to see you here again at some point later in next year. So yeah, that's all from the program for us, and just enjoy the rest of your time. You can finally ask all the questions to people that are still here, and yeah, just enjoy the rest of your day until the next time.
Next time, I am drawing 80 slides.
Good luck with that.
Get started now.
I said that many
Why
times.
did they? Wait, is next time in January or December?